This is what the cyborg future looks like. Most everyone is enhanced with technology. Many even surgically upgrade their bodies with powerful bionics. Computerized eye implants not only sharpen vision, but immerse users in seamless augmented reality. Cognitive devices connect brains directly to artificial intelligence, exponentially boosting intellectual capacity. Widespread machine integration is redefining what it means to be human.
My brain is melting.
Today, scientists are blazing a trail to this very future.
These devices are going to make us more powerful, more independent.
I want to know what breakthroughs are being made.
It's a radio that captures your thoughts in real time.
I'm improving the human body by implanting devices into it.
That will forge the future too?
Look, Ma, I'm a robot.
The Cyborg Revolution. My name is Angel Jafria, and I am a cyborg, a combination of human and machine that acts as one. I was born without part of my left arm, and I've been wearing a prosthetic device as long as I can remember. They used to call me the bionic baby.
This was my first ever multi-articulating hand. It was the big jump from this one grip pattern, this tripod, to being able to change the grip. I flex the muscles, it lets me move the hand.
As my arm muscles move, they affect 2 electrodes resting on my skin, which allows me to control my bionic hand. 4 years ago, I got my current prosthetic hand, and it's been a real game changer. It gives me finer motor movement and multiple ways to grasp things. As someone who started to merge with a machine, I can see that it both defines me and I define it. But I want to find out how cyborg technology like this will evolve for the entire human species. How far will the merging of man and machine go? And what will our cyborg future look like? My first stop on this path to the future is a personal one. At the Johns Hopkins Applied Physics Lab, they are developing bionic limbs even more advanced than mine. Costing upwards of $120 million to develop, the modular prosthetic limb, or MPL, is state-of-the-art.
I'm really excited about today because we get to see the MPL hand system, which is something I've wanted to see for almost a decade. I think I've dreamt about seeing this hand.
Engineer Robert Armiger is combining robotics, neuroscience, and artificial intelligence to make devices that will change lives around the world.
It's here in real life.
That's right.
Unlike my prosthetic arm, the MPL is designed to be upgradable, and it can be customized. It's also more dexterous.
You know, we've really tried to build in to this hand all of the sort of movements of the human hand. So see that each of the fingers is basically the ability to separate or spread the fingers here.
Cool.
These 2 are coupled together. This one moves independently.
Oh,
the middle
okay.
is fixed. All the fingers have a drive that flexes each finger, and then they've got this mechanism that allows them to passively curl around an object as well.
That's cool. I didn't know that existed.
It even has a powered, flexible wrist.
I want flexion extension so badly. I don't have flexion extension. I only have rotation, which is fun for a party trick, but I can't actually bend the wrist. So when I'm trying to put my hand in my mouth and stuff, I have to lift my shoulder. So when I see stuff like the flexion extension in that wrist, it makes me really excited that I could have it for my hand one day.
Bobby lets me test drive the MPL. First, he places armband sensors on me. Like my prosthetic arm, these bands contain electrodes which record and translate the muscle activity in my little arm.
We use electrodes that can pick up what's called the biopotentials of the human body. It's sort of the electricity that is flowing through your body to send commands to and from your brain.
With 8 times as many electrodes as my arm, these bands allow for much finer pattern recognition from my muscles.
Instead of just picking up like gross muscles, so these big muscle movements, it's picking up smaller, finer things.
Today, I'm getting a feel for some novel gestures and new capabilities.
All right, so when you're ready, so you're gonna start recording the no movement or rest state.
Okay.
And well, it's okay. It's learning the first time, so it may sort of confuse what you're doing because it's never seen this pattern before. You're introducing something new.
A computer inside the MPL reads the muscle movements from my arm and translates these complex patterns into movement in the robotic hand.
This is really cool.
The machine is learning more about me, and fast.
So I'm sending different muscles impulses, like to trying to see how much control I can have over it, of like the slow and fast. I was trying to do this, but that's cool.
This cyborg future emerged through the needs of wounded veterans and other amputees.
Johnny Matheny is one of the individuals that has spent probably the most time with the modular prosthetic limb, and he has really been able to show the capabilities of the arm because he has a surgical procedure that not only allows us to map the arm or attach it directly to his body, but then he's had the nerves in his arm rewired so that his control is natural and intuitive.
So what's next for it?
The fingertips are set up with active sensors inside of each of the nodes. What we've been working towards is some of the sensory feedback or stimulation to your arm, so you'll be able to actually feel what the hand is touching.
Okay. Can I? My brain is melting.
Without any feedback from my prosthetic hand, I can't tell how hard I'm grasping an object.
Like holding a styrofoam cup or trying to grab an egg, right? Where you're like, don't crush it, don't crush it, don't crush it, don't crush it.
The team at Johns Hopkins is working on this very difficult problem. Bobby's colleague, Dr. Luke Osborne, is enhancing the MPL's features with something called the eDermis. This incredible technology promises to simulate the sensation of touch.
Think about how much we rely on our sensation of touch, not just for grabbing objects, but also interacting with other human beings.
Right, yeah.
eDermis was made to mimic the way our natural skin behaves, and essentially we have different layers, and within those different layers we have different receptors.
Inside the skin, nerves detect pressure, pain, heat, stretch, and vibration. The eDermis is made from flexible fabric and rubber. And inside of it, tiny sensors detect various stimuli and translate them to the body's nerves.
Try to put it on?
On me or my prosthesis?
On your prosthesis.
Yeah. I've never really had that kind of feelings on the side from like touch and stuff. So it's also like a little scary, but exciting.
When I press on your fingertip, I can see the activity on the screen. So if you were to grab an object, we could see what the sensor activity would look like if you were to naturally pick up something.
That's so cool.
Luke's computer displays the pressure patterns from the eDermis for this sensation of touch. When these same signals are transmitted directly to my nerves, it gives me a sensation I've never felt before. It absolutely blows my mind.
And it's like pulsing over here. This is really cool. I think seeing this just makes me realize that we're on the path of doing some like really, really awesome things.
A bionic hand with a fine sense of touch will change lives and completely reshape the future.
The potential for this technology could be not only used for rehabilitation, but also for projecting yourself into some remote environment.
Like a remote control Iron Man, Bobby imagines a future where an arm like this could be used to perform complex tasks from just about anywhere.
In the future, advanced dexterous bionic arms are a common feature on most robots. These worker bots perform complex and delicate tasks in environments too hazardous for humans. From hundreds of miles away, skilled operators remotely perform nuclear cleanups, fight fires, and even repair the space station from the safety of Earth.
Mechanically enhanced humans have long been popular in sci-fi stories and superhero comics. As a partial machine myself, I'm excited by the real superpowers that our cyborg future will bring. But in everyday life, making cyborg technology work seamlessly with the human body is hard. When it comes to enhancing the human body with technology, balance is essential. Weight, speed, strength, these are all factors that must be considered when designing and engineering wearable robots. At Exobionics, Jason Jones is taking on the daunting challenge of bringing man and machine into sync.
Our main purpose is to enhance human capability through robotics primarily, right? So either for medical purposes or for industrial.
They've developed several true-to-life exoskeletons.
In my lifetime, I think you'll see more of people being augmented by machines. The approach we're taking is instead of replacing people, let's make it so they can do more. If they want to, they can work into older age because they have enhancement.
Jason's colleague, Zach Haas, shows me exactly how their exoskeletons boost worker productivity. This model is already being used in factories.
See how it feels?
I feel like I'm supposed to be really, really strong now.
Right.
Now that I have this on.
This is designed to really give sort of superhuman endurance.
Okay.
Yes.
I'll take that.
There you go. So now as you go to raise your arms, you'll feel it kick in, yeah.
Oh, okay. Yep.
Feel it?
Yep. And then,
What's it feel like?
like my arms are like free floating.
There you go. That's the key word there.
This free-floating sensation happens with mechanical spring-driven technology, which reduces strain on the arms from repetitive motion. It's so wild. I can absolutely feel the power and how it would transform industry. But for some, it might be intimidating.
Do you think there's a little bit of fear in the idea of like presenting some of these technologies?
Yeah, a little bit of sort of, there's just this idea. What is this a robot? Am I a robot now? Am I working with a robot? What does that mean? It's a machine that we're now strapping to your body.
Right.
It's got to work with you and you've got to work with it.
A little bit more personal.
A little bit more personal. So yeah, there's definitely more sense of trepidation there. But once people see the benefits, a lot of that disappears pretty quickly.
Look, Ma, I'm a robot.
Not only do exoskeletons boost human productivity, they can also restore locomotion to those who've lost it.
I'm gonna get to meet somebody who uses one of these exoskeletons and has this whole interface with technology like I do.
At the age of 32, Jess McNair experienced multiple strokes and lost the ability to walk.
It affected the right side of my body. It also affected my balance and vision pretty severely. It's been a journey.
With the help of physical therapist Jen Masievich, this exoskeleton is changing Jess's future.
1, 2, 3, push.
So cool. Can you explain to me what is actually allowing you to do things?
There's basically 4 motors. There's motors at the hips and then at the knees. And the ankle doesn't have a motor, but it actually allows us to position her for greater balance.
That's really cool.
So it allows someone to be fully weight-bearing, but also supported in a frame in a proper biomechanical position. All right, Jess, do you want to start the first step with the interface over there?
That's so cool.
An onboard computer uses feedback from sensors in the exoskeleton, and sophisticated algorithms process that feedback and then apply the proper amount of movement to each biomechanical joint. This coordination of man and machine represents a tremendous breakthrough. The exoskeleton is teaching Jess how to improve her gait.
We want them to be able to walk again. We want them to be able to step out of the device with a better walking pattern.
What do you hope to see in your lifetime?
The goal is to make it smaller, lighter, more adapted to the human body and less apparent.
So you wanted to be like more of a part of you then?
Exactly, yeah, more bionic.
Exoskeletons like these have humble origins. Early versions of this technology were clunky at best and seem laughable to me today.
One may witness a scientific endeavor to convert a man's legs into those of a giant.
But every evolutionary path must start somewhere, and our cyborg future is advancing fast. The team at Exo would know. They've also developed exoskeletons to assist with punishing physical outdoor tasks.
Carrying large, heavy loads over long distances or increasing endurance, that kind of thing.
These powered exoskeletons can help a person carry a 200-pound pack swiftly across rugged terrain. Incredibly, the wearer would only feel a mere fraction of that heavy weight.
These here are hydraulic cylinders, and they basically are kind of like a parallel muscle with your quads. So you can press down harder if you're walking up a hill, for example. It'll give you a little amplification. The design attempts to amplify your force, right? So if you're applying a certain amount of force, then it would add to that to kind of offset the effort that you're putting into it.
That's really cool.
In the back, you know, there's electronics in here, and there's a hydraulic pump and control systems.
And then we talk about mud and rain, obviously, the electronics.
Yeah, the challenges they're pretty big challenges in those.
I have those challenges myself, so.
Future versions of this cutting-edge technology will someday be widespread.
I think in the future, you'll see many people wearing assistive devices on a daily basis. I'm almost certain that those devices will be controlled at some level through interaction with the human's nervous system or their brain.
By enhancing our bodies with advanced robotic exoskeletons, we're taking a step closer to the Cyborg Revolution.
In the future, miniaturized, power-boosting exoskeletons are integrated into custom garments. With the press of a button, superhuman strength and endurance is available to everyone. This body augmentation reverses the decline of old age, restoring youthful vigor to anyone who still has a passion to work or explore.
In our cyborg future, wearable machines will augment our physical selves, and wearable computers will augment our minds with instant access to worlds of information.
I would wear wearables, yeah.
How will advanced wearable computers impact the way that people work, learn, and interact with their world? To find out, I've come to Atlanta to meet a true pioneer in wearable computing, Thad Starner.
For me, the real killer application for these wearable computers is augmented memory. Machines that become part of your mind, give faster access to knowledge, make you stronger in the sense that you have all this information you can use to help you on your day-to-day life.
So this was the first thing you worked on at MIT?
Right. Most people had no idea why you'd want a mobile computer because laptops weren't even out there yet.
While attending MIT, he became frustrated by his inability to retain what he'd learned in class. So Thad built this augmented memory system to take better notes.
You ready?
Oh, I'm gonna put it on.
So bring your fingers around like this. There we go. So now that is my daily suit in year 2000. So you'd have this plus a car phone plus a 7-pound lead-acid battery.
Do I look really stylish?
Actually, it looks pretty good on you, to tell you the truth. Yeah.
Though retro now, Thad's system had a portable computer, typing device, and a heads-up video display over one eye.
I found that once I had the ability to take notes in class, and especially this portable system, I took notes in person-to-person conversations. And that's one thing computers are horrible at right now, is assisting you during this sort of interaction.
Right.
But having a head-up display, you only use it when you need it, and it keeps your eyes in the world around you. And I find it to be really a good augmentation of the conversation.
The heads-up display overlays information within the user's field of vision. The system can be used to access applications or the internet. It can also augment your surroundings with information that only you can see. Thad eventually led a team that turned this tech into a commercial product, Google Glass.
That's the first functional one. We had to glue a cell phone to the side of our head to get a trackpad that worked.
That's wild.
Advanced smart glasses like these are making workers more productive in industries like manufacturing and healthcare. And it's easy to see why. By beaming information directly into the eye, the wearer can work on complex tasks, all while absorbing crucial information hands-free.
It's actually lasers in the side here that's bouncing off. If you get it just right, you can actually see a little mirror here. It's kind of hard to see.
Oh,
but
yeah.
You get it? Yeah.
Yep.
And so it bounces off the lens and back into your eye.
That's so cool.
Breakthrough technology like this is getting smaller every year. Even now, it's being developed for contact lenses. The Mojo lens is less bulky than smart glasses and completely invisible to others. When paired with a smartphone, they not only display information for the wearer, but also improve eyesight.
In the future, we'll see the technology disappear, it become widespread.
To bring man and machine even closer into alignment, that is developing another cyborg technology that actually teaches the body and brain new skills with no training or practice required.
This idea of being able to passively train these skills is something that's new. We haven't heard of it before. These are what's called muscle memory gloves, and they teach you skills like how to play a piano without your active attention.
How does it simulate? What's happening?
Okay, so let me show you the glove here. So what we got in here are little vibrating motors that are above the fingers.
Oh, things are happening.
Yep.
These vibrating motors emit a particular sequence on my fingers. This stimulates and trains the muscles in my hand to do something I've never done before: play the piano.
So she has a glove on right now. And what it's doing is it's using the vibration motors to actually tap each finger in the sequence of Beethoven's Ode to Joy. You will have that muscle memory in your brain.
After the glove has trained my hand for a half hour, it's time to see if it worked. I don't play the piano, so this will be interesting.
Okay.
So let's take off the glove here. She's gonna put her hand down, and we'll see if she can do it. We're kind of excited to see what happens. And you're gonna start there.
Okay.
So try your hand, right?
Having never learned to play the piano before, I've gotten the hang of it pretty quickly. By training the muscles in particular ways, these gloves rewire the brain, giving the user a jump start in developing fine motor skills for just about anything.
And we've been able to do that not just for piano pieces, but also for things like typing, for Braille.
Muscle memory gloves are already changing lives.
One of the things we're excited about is the rehabilitation side of these gloves. We can help people who have had partial spinal cord injury.
Like this man. The glove is even rehabilitating muscle coordination for people who've experienced strokes.
You can actually stimulate the hands such that people regain some sensation or dexterity. I really believe that these on-body devices are going to make us more powerful, more independent.
Wearables like these that augment the mind and train the body with new skills will usher in a cyborg future for all of us.
In the future, doctors wear muscle memory gloves in advance of complex surgeries to enhance precision and dexterity. The devices are tailor-programmed for each procedure to passively train the surgeon's hands. During the operation, augmented reality contact lenses provide a dynamic 3D roadmap of the patient's body. As a result of these protocols, success rates are soaring above 98%.
External machines won't be enough to make the merging of man and machine complete. We'll need to surgically integrate the technology inside our bodies. To experience this integration myself, I'm outside Seattle to meet a controversial biohacker. He's offered to implant a computer chip inside my body.
I'd heard a lot about it from some other people that I had met within this transhumanist community, which is like a group of people who believe in changing and upgrading your body.
Like most transhumanists, biohacker Amal Grafstrup believes technology will fundamentally change the human species, helping us evolve beyond our current physical and mental limitations.
I'm improving the human body by implanting simple devices into it and then change my capabilities as a human being. That's biohacking.
Amol has turned himself into a lab rat for his own inventions. He has 5 functional devices implanted across his body.
So,
Those are implants.
These are implants, yeah. So and they would just go, you take a 4-gauge needle, make a pocket, and then just slide it in.
Very cool.
There it is. So this is the new size of this prototype, this huge one.
Yeah.
Giant 35mm diameter implant, right?
That's a big one.
That's a big one. I've had it for a while.
Each chip serves a particular purpose.
This is like a payment card from the EU. I'm converting them into implants for people.
Imagine that, paying with the swipe of your hand. But integrating machines into our bodies has led to a lot of resistance.
So from when you first started out, do you feel like people have gotten more receptive?
In general, yes. So in 2005, when I put this in my left hand, the first one, the reactions were very visceral.
Right.
What are you doing? You're crazy. Oh, we should get him, like he's supporting the government New World Order. That kind of thing. And now, you tell somebody on the street, I got a chip implant, they're like, oh, I heard about that.
However, as society becomes more receptive to the idea of cyborg technology inside the body, new ways of using it will emerge. By incorporating magnets into his body, Amol has found that he has created an entirely new biological faculty, giving him an unprecedented sixth sense.
Your magnet you were able to feel the fields.
Yeah, magnetic field.
You adapted to that.
But yeah, you adapt to it immediately. And that, to me, again, says that this is part of who you are now.
The implanted magnet rewired how his brain and body experienced reality, giving him a new magnetic sense.
I took it out after about a year, and there was a real sense of loss.
Amol's not the only one out there in these uncharted waters. Cyborg artist Neil Harbison has a cyborg antenna implant, which senses colors, including ultraviolet and infrared. The implant allows him to both feel and hear colors as vibrations inside of his head. Engineer Kevin Warwick had a chip implanted in his arm that directly connected his nervous system to the internet. It's clear we are already on the path towards the full integration of man and machine.
Where do you think, technology is going in general?
On one hand, it's very exciting and cutting edge, but also it's nothing new. Like, human beings have always been leveraging technology since we picked up rocks and sticks, right? It's just that technology's been external. The technology that's gone into our bodies has always been kind of medical and restorative.
Right.
And this is an enhancing, augmentative technology. So there's some trepidation about breaking the skin barrier for a non-medical need, right? But overall, the trend for human beings is to make technologies that enhance our capabilities.
With my bionic arm, I know this to be true firsthand. But getting another enhancement under my skin, I'm not so sure about.
You ready?
I am,
Yes?
I'm ready, yes.
Okay.
The answer is yes.
The answer is yes. Okay, good. Here we go.
Amol is implanting a VivoKey chip into my fleshy hand.
Take a deep breath. Here we go. Yay.
This new implant will give me a unique electronic signature.
Very cool.
With it, I'll be able to unlock all kinds of devices and pay for things with a simple swipe of my hand.
I think that it's going to be a point where everyone's chipped at some point.
There's going to be something. It might not all be the same chip. Some people might have like a glucose reader.
Right.
Some people might have something else. Some people will have a cognitive implant. It's to the point where we can just put it in our bodies and it becomes part of who you are now.
Yeah, I love that.
Let's see if this thing actually works.
So go ahead and press the button. And now back of your hand across there. Just like that.
Cool.
Integrating chips like these into the human body will unlock doors to our cyborg future.
In the future, multi-feature chip implants the size of a pinhead replace most wallets and mobile phones. Everyone just swipes their hands to pay, unlock everything, and confirm personal identification. The magnetic sensor enhances orientation, operating like a compass. It lets users feel direction. No one ever gets lost. Biosensors measure vital signs and blood chemicals. At the first sign of a health issue, physicians are notified for preemptive treatment.
If It's pretty easy to see how cyborg technology can improve the body. But integrating it into the human brain is a far more complicated and dangerous task. Neuroscientist Dr. John Donahue is forging the difficult path to this very future.
We're in Providence to meet with Dr. John Donahue, talking about implants. Like I have the implant in my hand. He puts them in your brain.
John led a pioneering team that created one of the first brain-computer interface devices. It's called BrainGate.
We actually peer into the brain and look at thinking about movement. When we first put an electrode in the brain, we didn't know whether somebody could control anything.
To decipher the connection between thought and action, John implanted the BrainGate device into Matt Nagel, a quadriplegic. Matt was able to control a computer cursor directly with his mind.
So the whole idea of a brain-computer interface is to help a person who is paralyzed to be able to move again or be able to communicate or interact with the world.
Open.
John achieved this breakthrough by using computers to read the brain signals inside Matt's skull. The first technology to do this was developed in the 1920s by German psychiatrist Hans Berger. He invented an instrument he called the electroencephalogram, or EEG. The device measures the brain's electrical activity through the skull and represents it as complicated lines on a graph. However, decoding these brainwave patterns is an immense challenge, especially when the goal is to control complex movement.
Imagine that those signals coming from your hand to control that were not coming from your hand, but from your brain. And now you don't know what makes your brain cells active, so how can you relate what your brain cells are doing to that motion? And we didn't know whether anybody could ever learn to do it.
With BrainGate, John took the next very difficult step of deciphering a person's mental intention to move their body.
So the first thing we have to do is we have to go to a place in the brain that has those signals. Then we need to be able to sample the activity in the brain.
This involves surgically implanting tiny electrodes in the region of the brain that controls movement, the motor cortex. The electrodes directly observe and measure the activity of the neurons located there.
Each neuron talks to lots and lots of other brain cells, other neurons, and it creates electrical impulses that are the communication language of the brain. Each one influences the other, and collectively they generate patterns of activity.
And the tiny electrode array picks up these patterns.
This electrode array is basically 100 needles.
Oh my gosh.
Yeah. So each one of these is what the electrode is recording, and that is the electrical impulse of the neuron emitting its electrical impulse. So we actually aren't trying to interpret just that cell all by itself, but how does it fit in everything all together? It generates a pattern.
Understanding this pattern is like putting together a 1,000-piece puzzle without a picture for reference.
Our job is to take a look at all of those activity patterns and try to make sense of what they actually mean. And what we use is a computer to translate. It is really like translating a foreign language. And so what we do is we tell the computer basically, when you see the pattern that was recorded when the person thought about moving left, if you see that pattern again, then move to the left or move a computer cursor to the left.
Using artificial intelligence, John can translate those brainwaves into a physical action far more complex than just moving a cursor. Kathy Hutchinson, who was unable to move or speak because of a stroke, was the first person to use BrainGate to control an external robotic arm and hand. This leap forward will change the lives of countless people. But there's a big problem. The electronics required to amplify and translate these brainwaves are the size of a washing machine. How will technology like this integrate into the body to create a self-contained cyborg? John has the beginnings of a solution.
This wafer, which is something like 4 by 8 millimeters, it has 1,000 electrodes on it. But what's even cooler, that little square is equivalent to 10 of these things, all in a chip. What do we need to do to implant this in a human? We have to figure that out. Then we have to ask users, what do you want? If it has to be something sticking up like a box on your head, Actually, I worried that you would say that's cool.
You know me so well already.
But most people wouldn't want to do that.
Yeah.
Even though chips like these are small, they'd still need to connect to external computers with a tangle of wires.
Given that electronics can do this, that neuroscience is not quite up there, but we're pretty good, that all of that information pooled together will get us there. We can do it.
The Cyborg Revolution depends on advanced versions of integrated brain interfaces like this to read our most complex thoughts and intentions. But making devices like this that stand alone in the brain is not as far off as one might think. In a nearby lab, engineer Arto Nurmiko is developing tiny chips that will not only interface with the brain, but connect wirelessly.
So the first thing is to cut the cable in order to particularly endow more mobility for a subject. So he or she is not tethered to these massive volumes of electronics.
He calls these prototypes neurograins.
They look like glitter.
What they are individual tiny little chiplets about the size of a grain of salt each. And they have internal electronics. There we go, that's neurograin. The physical size means that there is safety in implanting such tiny little objects in the brain without causing damage.
Thousands of neurograins could be distributed across the surface of the brain to record and broadcast neural activity wirelessly.
Each one of these little chiplets would be like a little cell phone that's able to capture some of these neural signals and then spew them out, streaming your thoughts in real time.
That's wild to think about.
Using computers, Arto is developing cutting-edge techniques to interpret these complex signals.
We use machine learning to decode or understand what those 10,000 little cell phones are actually telling you or me about my intention or your intention, not only to move an arm, but perhaps do much more complicated movements.
This same technology could also be used like a two-way radio, not just sending, but receiving thoughts as well.
If we project forward and begin to contemplate, or at least imagine the possibility of using electronic methods of communication with the brain for people who don't have any particular disability.
Right, enhancements over restorative.
Right, exactly. So that's how the concept has taken its first steps toward reality.
It's really cool.
Connecting the brain with machines, allowing a person to send and receive thoughts, would be a monumental breakthrough.
In the future, brain implants replace computers and connect wirelessly with the internet. Electronic communications like emails and text messages are composed and sent using thoughts alone. Mental snapshots and dreams can be uploaded to the cloud and shared with friends. Every word in any language, written and spoken, is directly translated and accessible to any brain. Now that humans off-source mental chores like memorization, the full potential of the human brain is unleashed.
Throughout human history, so-called psychics have claimed, dubiously, that they can read people's minds. But as we blaze a trail to the cyborg future, reading thoughts, aided by technology, seems more and more possible. But how would that kind of telepathy work? I'm in Seattle to meet Dr. Rajesh Rao, who's actually developing science-based telepathy.
We began thinking about this idea of extracting information from a brain and send it to a different person. Computer-assisted telepathy, brain-to-brain communication.
This radical technology lets individuals use computers to telepathically control other people.
So what kind of reaction have you gotten to your research? Do people think it's cool or kind of scary or?
All of that, actually. So you had reactions ranging from, it's amazing, it's cool, it's so sci-fi, to people who are scared about this kind of technology.
But when people adjust to the concept, this is what the cyborg future will look like.
Are you ready to interface?
Yeah, I think so.
And I'm going to give it a try.
So you'll be wearing a brain-computer interface cap that will be tapping into the electrical signals that we're measuring at your scalp, which in turn reflects the underlying brain activity.
Oh, wow, look at this room.
Rajesh's team fits me with a 32 electrode EEG cap. The cap will observe and measure the electrical activity of my brain.
All right, great. So right here, and I'll manage his wires.
The computer reads the signals from the EEG cap to interpret my intentions. Does this look cool? Do I look cool?
Oh yeah.
Yes.
You look like you're from the future. Even more so.
Even more so. I was like, yeah. My mission is to play a video game through another person using computer-assisted telepathy. If this works, my brain will actually control the other person's body.
Oh, we're almost there, Preston. 11. I think we're good.
We're good?
Yeah.
And here's the kicker. The other player will not see the video game at all.
So what we're going to do is have you control a cursor on a computer screen, and that message is going to be sent over to Jane here.
So Jane will be receiving your thoughts through this TMS, transcranial magnetic stimulation device.
Yeah, I'm excited to feel your brainwave.
All right, let's figure this out. The TMS device uses pulses of magnetic radiation to stimulate the neurons in Jane's brain.
It'll send a message to the motor cortex region of her brain, and that in turn will cause her hand to move. And in turn, it'll allow her to, play a computer game that she's not seeing.
Let's see if this wild contraption works. My goal is to use my thoughts to control Jane's hand.
If you want to send a yes signal, you just pay attention to the left light. And by focusing on that, the ball should move to the corresponding direction.
By concentrating on the area of the screen that says either yes or no, I can move the cursor left or right to indicate my choice just by thinking about it. When I select yes, Jane will receive the stimulation in her brain from the TMS device to click her computer mouse.
No stimulation.
Now it's time to see if I can send a signal to Jane's brain just by thinking and selecting yes.
Yes.
Really?
Yeah.
What did you feel?
There's a little tap at the back of my head, and then my wrist and my fingers just moved.
Using my thoughts alone, computer-assisted telepathy lets me control another person's physical movement.
I know I'm not thinking to move it. My hand just moves. It's like a reflex, like when someone kicks your knee and it just moves. That's what it feels like.
That's so weird. Rajesh is using this technology to forge a cyborg future even more mind-blowing.
Our goal is to connect brains together such that the connected brains can solve a problem that none of the brains individually could solve.
Networking the minds of entire communities and industries together could radically transform society.
As the plan to have more people to have the whole net kind of thing?
Yeah, so in the future, maybe you can unleash the kind of creativity that a single person cannot. So by having many brains collaborate on a project together, perhaps you can solve very hard problems.
By networking brains with complementary strengths, the whole would be greater than the sum of its parts. And with this kind of mind-melding cyborg synergy, humankind might invent new forms of green energy and reverse global warming, decipher the mysteries of human consciousness, or even answer the question of what happened before the Big Bang. The sky is no longer the limit. But with any new and disruptive technologies, society needs to weigh the benefits against the risks. How cyborg technology will change the world is unpredictable.
As with any device, we need to look at the privacy and safety issues, more so in the case of brain-computer interfaces, because it has the potential to change who you are.
It's easy to take for granted that the contents of our brains belong to us. But in the cyborg future, that might not be the case. That personal, private information that makes every person unique could potentially be abused.
In this world of neurotechnologies, ethics is hugely important. You could call the invasion of your brain as being the ultimate sacrifice or ultimate leap. Or you could say Well, it's just another increment in the pathway of losing the ultimate privacy, which is the privacy of your own thoughts.
And in the future, who will benefit from things like cognitive enhancement? Will the privileged be the only ones that can afford to download a lifetime of learning into their children's brains? Or will everyone gain access? The Cyborg Revolution has the potential to upend society. But many are excited about the transformative possibilities of a cyborg future.
Let's imagine we're linked neurally, right? Yeah. We lose the language completely, and now it's just thoughts and feelings and concepts and like, who knows, right? So it could definitely fundamentally change humanity.
I really believe that this technology can, when it becomes part of us, make us more of what we really are, which is human.
Despite some valid concerns, I'm hopeful that science, technology, and the human spirit will find helpful solutions. As for me, I expect everyone will become a cyborg one day. And I can see a future where individuals choose to upgrade their physical body parts with robotic ones once they have better features. The Cyborg Revolution is coming. And as a cyborg myself, I couldn't be more excited.
This is what the future of hyperintelligence looks like. Most people no longer own cars. Instead, artificial intelligence operates fully electric, networked, self-driving vehicles. As a result, air pollution and traffic congestion plummet across the planet. Self-navigating aerial drones are on the front lines for disaster response and search and rescue missions. Most people live and work side by side with self-aware androids. These AI companions boost productivity and liberate humans from tedious tasks, completely revolutionizing modern life.
I feel like I'm in a superhero movie.
Today, scientists are blazing a trail to this very future.
The fact that we're enabling the system to make its own decisions, I don't even know where to begin with that.
I want to know what breakthroughs are being made.
It's talking and it's having this dynamic conversation with you. That's the wonder.
Machines can be self-aware in ways that we can't.
That will forge the future to, oh my gosh, it's looking at me, hyper-intelligence. My name is Shivani Bigler. As an engineer and neuroscientist in training, I'm obsessed with artificial intelligence. As a kid, my father took me to tech and robotics trade shows, where I became dazzled by science. Every year, the inventions were smarter and smarter. Artificial intelligence has come a very long way in the last couple of years.
Most AI technologies are programmed to think for themselves, to learn from examples, kind of like simulating human intelligence in a way that it learns from past experience.
But how does AI actually work? In the future, will AI achieve human traits like emotions, consciousness, or even free will? And how will humans and robots work together? Today, the clearest road to the future is the self-driving car. Unlike a regular car, which is just a machine, a self-driving car is a robot that can make decisions. In the future, will every car on the road become driverless? To find out, I've come to a hotbed of self-driving car research, Pittsburgh, Pennsylvania.
Every single person has started to have conversations about self-driving cars because essentially they're the future. But in order to understand it, we have to look under the hood.
Making decisions on the fly, even simple ones like these, does not come easy for computers. To discover the inner workings, I'm meeting a true pioneer in the field.
Please get it.
Thank you.
Dr. Raj Kumar of Carnegie Mellon University. Carnegie Mellon is the birthplace of self-driving car technology, thanks in large part to the work of Raj and his colleagues. They've been the leading innovators in this field for more than 25 years. So how does his self-driving car make decisions to safely navigate the world like a human driver?
Should we get started? I'm pretty eager.
Yes, we can.
Since Raj is distracted by our conversation, for safety reasons, the state of Pennsylvania requires another driver in the front seat to monitor the road.
This is so cool. I'm nervous but excited. What's the longest you've ever driven a vehicle autonomously?
We have gone hundreds of miles.
Awesome.
I'm going to go auto by pressing this button.
Oh my gosh. It really is driving itself.
While most self-driving cars are built from the ground up, Raj just bought a regular used car and hacked it with powerful onboard computer systems, making it more adaptable than other regular cars.
We installed a bunch of sensors in them. It is able to shift the transmission gear. It is able to turn the steering wheel, apply the brake pedal and the gas pedal. It's really the software that runs on the computers that makes this capability really practical. And there are some very key fundamental artificial intelligence layers that tries to mimic what we humans do.
To mimic human decision-making, most self-driving cars use a combination of cameras and advanced radar to see their surroundings. The AI software compares external objects to an internal 3D map of streets, signs, and transportation infrastructure.
A map is something that is static in nature.
Right.
Traffic and people and objects are dynamic in nature. The dynamic information it figures out on the fly.
Comprehending dynamic information allows it to understand where it is heading objectively in space and react to changes and traffic signals.
It recognized the stop sign.
Yes. Since we are pedestrians, we definitely should not be running into that person. The AI challenge to make a vehicle drive itself is not an easy task. Safety is priority number 1, and priority number 2 and number 3 as well.
But what happens when the AI system doesn't understand specific objects in its surroundings?
A pedestrian in Tempe, Arizona was killed last night by a self-driving taxi. It's believed to be the first fatality caused by an autonomous vehicle.
This tragic accident happened because a self-driving vehicle didn't recognize something in its environment, a jaywalker. In the future, advanced self-driving cars will have to make life and death decisions on the fly. If avoiding the jaywalker means crashing head-on with another car, potentially killing the driver, what should it choose? How will scientists address monumental problems like these? The first wave of artificially intelligent robots were programmed by engineers with static sets of rules to achieve their goals. These rules are called algorithms. But not all rules work in all situations. This approach is very inflexible, requiring new programming to accomplish even the smallest changes in any given task. A new approach called machine learning has changed everything. With machine learning, computers can absorb and use information from their interactions with the world to rewrite their own programming, becoming smarter on their own. To see machine learning in action, I'm meeting another Carnegie Mellon team at an abandoned coal mine. Dr. Matt Travers leads a group that won a challenging subterranean navigation competition held by the Department of Defense's research agency, DARPA.
They're affectionately known as R1, R2, and R stands for robot.
These robot twins are designed for search and rescue missions too dangerous for humans. And unlike the self-driving car, they operate without a map. To achieve this, they have to learn to identify every single object they encounter on the fly.
They are programmed to go out and actually act fully autonomously. And they will be making 100% of their own decisions. So they're recognizing objects, they're making the decision of where to go next, where to explore.
To see this in action, the R2 robot is starting on a simulated search and rescue mission to find a stranded human dummy in the mine.
Imagine having a map of a collapsed mine before you sent a team of people to go rescue someone in that mine, right? Like, it's a game changer.
How the robot discerns elements in this environment parallels how an infant learns about her environment. A 3-month-old uses her senses to cognitively map out her environment and learn to recognize her parents. She ultimately uses this map to interact with everything in her world. Just like this robot.
Okay, so we ready to roll?
Artificial intelligence makes this learning curve possible. But how does it create its own map and identify a human on its own? And without an internal mapping system like the internet. Test engineer Steve Willits shows me how the R2 robot can detect a stranded person.
When you're in a search and rescue scenario, that's the kind of situation where you'd want to deploy one of these.
As it explores and maps the cave, it drops devices called signal repeaters to create a Wi-Fi network trail.
It drops those just like breadcrumbs along the path.
Using this network, the robot sends data back to home base to create a map. At the same time, the robot must look at every single object to identify the stranded human.
So the LiDAR system is giving a full laser scan.
LiDAR stands for light detection and ranging. Similar to its cousin, radar, which uses radio waves, LiDAR systems send out laser pulses of light and calculates the time it takes to hit a solid object and bounce back. This process creates a 3D representation of the objects in the environment, which the onboard computer can then identify. This process is similar to how the eye feeds visual data to the brain, which then recognizes the objects by tapping into our pre-existing knowledge of what things look like. By fully understanding its environment, R2 can then make better decisions about where to go and where not to go.
What our robot's doing right now is exploring. So the robot came to a junction, and off to the left, it could see that it couldn't get past.
Right.
So it saw the opening to the right, and that's where it went.
It kind of looks like it's making decisions about whether or not to climb over these planks and obstacles all up in this area, right?
That's exactly what it's doing at this point.
Just like a baby, R2 learns through trial and error. It's like a little dog wagging its tail. But there's no one here to rescue, so it moves on. As R2 continues to map out the mine, oh my God, a human! It stumbles upon its intended target.
That is Randy, Rescue Randy.
Hello, Rescue Randy. Scared me. With the discovery of Rescue Randy, the R2 robot can not only alert emergency personnel, but also give them a map on how to find him. That is incredible. It knows what it's doing. These incredible rescue robots are clearly paving the path to the future of hyperintelligence.
In the future, autonomous exploration vehicles perform search and rescue missions in every conceivable disaster zone, even in avalanches atop Mount Everest. Incredibly, intelligent off-road vehicles are also mapping deep cave systems previously unknown to science, discovering a vast supply of rare earth elements essential for modern technology.
Artificial intelligence will clearly save human lives in the future, but there's a lot of terrain on Earth that's too difficult to navigate on wheels. How will intelligent robots make their way over rainforests, bodies of water, or even mountaintops? In Philadelphia, Jason Derenick of Exyn Technologies is working to overcome this problem.
What we focus on is autonomous aerial robotics to enable drones to safely navigate in unknown or unexplored spaces.
Jason's team has built the first industrial drone that can fly itself, anywhere. Incredibly, these autonomous robots navigate without GPS and map their environment as they go.
We focus on all aspects of autonomy, which includes perception, orientation during flight, motion planning, and then finally control.
But going from 2 dimensions to 3 dimensions requires an increase in artificial intelligence processing. The mission for their drone is to fly independently through a 3-dimensional path from one end of the warehouse to the other.
Starting mission, 3, 2, 1.
Now, to mess with its computer mind, Jason's team places new and unexpected obstacles in its path. Will the drone recognize these unexpected changes? Will it get lost? Will it crash?
Essentially, we have a gimbaled LiDAR system that allows the vehicle to paint a full 360 sphere around it in order to sense its environment.
Like the robot in the mine, this aerial robot uses LiDAR to see.
It actually generates a voxelized representation of the space, which you see here. And each one of these cubes in the space, it's trying to determine whether that cube is occupied or whether it's free space.
The robot's onboard computer makes real-time decisions of where to go based on its visual input. Kind of like us humans. Incredibly, the drone recognizes the whiteboards and flies around them.
One of the things about this system that make it particularly special is that it's actually being used in the real world to keep people out of harm's way.
Autonomous drones like these are already at work in hazardous industries like mining, construction, and oil exploration. They safely conduct inspections in dangerous locations and create detailed maps of rough terrain.
From a technological perspective, the fact that we're able to do everything that we're doing on board, self-contained, and enabling the system to make its own decisions, I don't even know where to begin with that.
Self-flying robots like these will revolutionize search and rescue and disaster response. They could also transform how packages are delivered. But there are limits to what large, single drones can do. More complex tasks will require teams of small, nimble, autonomous robots. Dr. Vijay Kumar at the University of Pennsylvania is working with swarms of drones to perform tasks like play music or build structures cooperatively. He's also developing technologies to tackle some very big problems, including world hunger.
In a couple of decades, we'll have over 9 billion people to feed on this planet. Of course, that's a big challenge.
To take on a task this big, he's building an army of small flying robots with the ability to synchronize.
We think about technologies that can be mounted on small flying robots that can then be directed in different ways, like a flock of birds reacting to a predator or a school of fish. You have coordination, collaboration, and it all happens very organically.
Using AI to get robots to work as a coordinated, collective group is a daunting task.
3-5 years ago, most of our robots relied on GPS-like sensors. Today, we have the equivalent of smartphones embedded in our robots, and they sense how fast they're going by just looking at the world, integrating that with the inertial measurement unit information, and then getting an estimate of where they are in the world and how fast they're traveling.
This I gotta see, and I'm gonna check it out virtually as a robot.
I'm at UPenn, remotely in Vijay Kumar's lab. Sample my surroundings. Oh, I hit something. Hello.
Hi.
Vijay's apprentice, Dinesh Thakur, is my guide.
Today we are going to show robots flying in a formation.
Great, can we see how that works?
Sure, yeah.
The first step Dinesh takes in coordinating the drones is to provide them with a common point of reference. In this case, a visual tag similar to a basic QR code. Using only the onboard camera, these drones reference the code on the tag and visualize where they are in space. Using sophisticated bio-inspired algorithms, the drones then figure out where each other drone is within the collective swarm.
These drones are communicating with one another, right?
Yeah, right now they're communicating over Wi-Fi.
So cool.
Future versions of these drones will create their own localized wireless network to communicate. But for now, this swarm is a proof of concept.
You've defined a formation and then they're assuming that formation?
Yeah, I just say I want to form a line, and the drones themselves figure out where they should go.
Once they figure out where they are in relationship to each other, they can then work together to accomplish a shared goal, like ants working as a collective entity.
Once they can coordinate between each other, we can send them out and doing specific missions.
That's really cool.
Swarms of flying robots have their advantages. Unlike a single drone, self-coordinating swarms can perform complex operations, like mapping, much faster, by working in parallel and combining their data. And losing one drone in a swarm doesn't doom the whole operation. Vijay imagines employing his advanced swarm technology to work on farms. This precision agriculture will help feed the world's growing population.
We'd like robots to be able to roam farms and be able to provide precise information about individual plants that then could be used to increase the efficiency of food production. That would be a huge impact in a world. This is our duty as responsible citizens and as responsible engineers.
This high-flying approach towards resolving the problems of the future is definitely a path I can get on.
In the future, artificial intelligence coordinates flocks of drones to protect the environment and boost the food supply. To combat the negative effects of climate change on agricultural crops, robotic bees assist with pollination in orchards and on farms, making them more sustainable and productive. Fish-shaped underwater robots automatically deploy at the first sign of an oil spill. These drones create a barricade to rapidly contain spills, saving marine life and oceans across the world.
Modern society has a long history of building robots to do work that's dangerous, difficult, or too repetitive for humans. AI is poised to automate all kinds of tedious work, ranging from factory work to taxi driving to customer service. While some are worried that smart robots will replace human labor, that's not necessarily the case. As a sector, artificial intelligence is expected to generate 58 million new types of jobs in just a few years. So what will the future of human-robot interaction mean for our work and livelihoods? I'm at the Massachusetts Institute of Technology to meet Dr. Julie Shaw. She's leading groundbreaking research in human-robot collaboration.
My lab works to develop robots that are effective teammates with people.
Julie and her team are creating software that helps robots learn from humans, even giving them insight into different human behaviors. By being aware of real people, robots can directly work and interact with them.
How do you teach these robots or machines to do these human-like tasks?
The first step, as it would be for any person, the first thing they do is become immersed in the environment and observe. And then we need an active learning process. The robot needs to be able to communicate or show back to the person what it's learned. We don't want the robot to learn the direct sequence of actions. We want the robot to learn this more general understanding. That's ultimately our challenge.
But getting a robot to grasp the bigger picture concept in order to understand the basics of its task in the first place requires a lot of observation and, well, hand-holding.
My research is focusing on trying to make robot programming easier by trying to teach robots how to do tasks by demonstrating them.
Julie's colleague, Ankit Shah, shows me how this robot is learning to set a table.
So this is all the silverware and the plates, the bowls, the
Right.
cups, and this is the table that it has to set.
Yes, that is correct.
Okay.
As any parent knows, the first step in helping a child to learn is to model the desired behavior. It's the same with machine learning. In this case, the AI robot recognizes the objects with a visual tag similar to a QR code, and for 2 weeks, it observes Ankit setting a table.
So did you pick up an item and then place it on the dinner table?
That's basically what we did. And based on that, the robot learns what it means to set a dinner table.
Dynamic tasks like setting a table or doing laundry are easy for humans, but incredibly hard for robots. The software has difficulty with so many variables, and even subtle changes in their environment can throw them off.
One of the things which I like to do is to actually hide some of the objects, so it's not going to see the spoon. And the reason we do this is we want to show that the robot is robust to some of the disturbances in the task.
The robot's software has learned what each object is and where it goes. Now, let's see if it's learned the concept and can think dynamically to set the table.
So you can just pick up the card.
Here we go. I've revealed the spoon.
Incredibly, the robot recognizes the spoon and instantly places it next to the bowl. This reveals that the robot has learned the concept and executes the right action dynamically. In the process, the software is continuously writing and revising its own computer code. Basically, it's learning. If, like humans, robots can grasp the bigger picture context and not just the mathematical tasks, will AI-driven robots of the future spell the end of having to work?
The key aspect is not developing AI to replace or supplant part of the human work, but really understanding how we fit them together as puzzle pieces. People work in teams to build cars, to build planes, and robots need to be an effective team member.
It's real teamwork. As if you're in a basketball game, you have your goal, right? And you have to think spatially, who am I gonna pass the ball to? And at what time you do that so that everything matches up.
The analogy of a basketball team is outstanding because we actually need to know spatially where they're going to be, and the timing is of critical importance. And so we need to develop the AI for a robot to then work with us.
One of the most difficult aspects of creating hyper-intelligence is actually something that even we humans sometimes get wrong. And that is anticipation. Anticipating what a teammate or coworker might do requires understanding of contextual information on a much more sophisticated level, and predicting what will happen next. Can robots make predictions as accurately as we can?
Abby's our industrial robot.
Penn Lasota is giving this Abby machine the intelligence necessary to help it anticipate a human coworker's action.
This is a simulated manufacturing task that we have set up to simulate some sort of task that a person or robot could feasibly work on together.
For safety reasons, actual human-robot interaction is, at present, fairly minimal.
Typically in a factory, you would see these guys behind a metal cage, and you wouldn't have people working with them. So what we're trying to do is make something that a person could safely interact with.
What is human and robot supposed to do together in this task?
In this task, a person's placing fasteners in some surface of a plane and a robot applying like a sealant over to seal in.
Okay, can we see it happen?
Sure.
In order to work together, the robot must first be able to see and recognize the actions of its human counterpart, and adjust to the person's every move.
Ooh, feel like I'm in a superhero movie. So the cameras in the room can see these lights and track your hand so that your hand doesn't get cut off by the robot.
That's right, yeah. So the cameras and the lights basically work as eyes for the robot. So that's how the robot knows where I am.
The monitor shows the visual representation of the room that's inside the robot's mind.
So this is what the robot might be doing if, I'm not in its way and the robot's just sealing and I'm not supposed to be here.
PEM does something the robot has no way of expecting.
If I put my hand in a robot's way.
Oh, wow.
By quickly understanding this human action, the AI software reacts accordingly. By stopping.
It's important to be able to share the workspace.
Building on this sense of teamwork, PEM's next step is helping Abby anticipate where he will move next, based on subtle, contextual cues.
So in this case, the robot will not only track which actions I've done so far, but also anticipate which portion of the space I'm going to be using.
Okay.
And when it's planning its own motions, it'll avoid those locations so that we can more seamlessly work together.
Oh,
so
okay.
what you'll see now is after I place this bolt, the robot's going to predict I'm going to go to this one next. So what you'll see is it'll behave in a different way. So now that I place this bolt, the robot kind of takes a more roundabout path that allows me and the robot to work more closely together. And I don't have to kind of worry about it crashing into me because I can see that it's trying to avoid me. So similarly on this side, I place this bolt. You see the robot takes a more kind of like roundabout path.
Yeah, because they're going to go there next.
It's slowed down because it's close to me.
Right.
Work together at the same time. So not only is the interaction more efficient in that the robot's not spending too much time standing still, it's safer because the robot's not constantly kind of like almost hitting me, and also feels nicer for the person working with the robot.
I really love this theme of teamwork.
Programming robots to coordinate with us and anticipate where we will move won't only revolutionize the workplace, but it will also change society at large.
In the future, the coordination of man and machine is so advanced that this collaboration increases productivity and accuracy in most industries. AI robots now accompany surgeons in hospitals across the globe. They anticipate the doctor's needs and hand them the appropriate medical tool just before it's needed. This dramatically reduces surgery times and human error.
As machines become smarter in their interactions with humans, will they ever develop consciousness? And will artificial intelligence actually surpass human intelligence? While some machines have exceeded human ability in games like trivia,
now we come to Watson,
and chess, these AI systems were designed to master just a single skill. These programs use brute force computer processing power and specially tailored software to beat their human opponents. To achieve the holy grail of hyperintelligence, scientists must develop systems with flexible, human-like abilities to both learn and think. This form of smarts is called artificial general intelligence. I'm back in New York City on my own campus at Columbia University to meet with Dr. Hod Lipson. Hod's lab is developing creative robots that paint original artworks, self-assembling robots, and even robots that learn about their world without human assistance. But his ultimate goal is even more ambitious.
Can a machine think about itself? Can it have free will? I believe that, in fact, machines can be sentient, can be self-aware in ways that we can't.
As a neuroscientist, I know we've only scratched the surface of our scientific understanding of how consciousness works in humans. How could one possibly use computer code to put this transcendent feature into a robot?
Our hypothesis is actually very simple. It is that self-awareness is nothing but the ability to simulate oneself, to model oneself, to have a self-image.
The first step towards creating robotic consciousness is to teach the software to build an image of its physical, mechanical self inside its computer mind. We humans take consciousness like this for granted, even in simple moments, like understanding our own image reflected in a mirror. Humans start to develop awareness of their own emotions and thoughts around the age of 1. This helps babies understand their self-image in their minds, and it helps them to learn about their environment and their role in it.
When a robot learns what it is, it can use that self-image to plan new tasks.
In both humans and robots, awareness about the physical self is called proprioception. Neuroscientists sometimes call this self-awareness of our bodies a sixth sense.
We use the same test that a baby does in its crib. A baby moves around, flails around, moves its arm in ways that look random to us, but they're not random, and then it touches its nose, right? Now, if its brain predicts that it's going to feel something, and it actually feels that, that means that its self-image was correct. Same thing happens with a robot.
If proprioception can be developed to the same level as humans, this could lead to robotic consciousness. Hod's colleague, Rob Kwiatkowski, is the proud parent of a brand new baby robot that he built. And by interacting with its surroundings, it's in the process of developing its own internal self-image.
So what are these claws?
So these are actually feet. They're designed for walking on carpet, but as of now, it doesn't really walk. It's still kind of a baby. It needs to learn how the world works first.
What do you mean it's still kind of a baby? What is it doing?
Like a baby, it's sending completely random actions to each of these robot arms and really try to get an understanding of itself primarily.
It looks like a spider that doesn't know how to use its legs.
Yeah, I guess that's a pretty good way to put it, yeah. So it will really be learning by doing this babbling for somewhere on the order of a day to a week. It will process this data to create an informative model of itself. And from there, imagine how it would walk, and then execute that walking in the real world.
These are the first baby steps towards developing its self-image. And like a baby, it will eventually learn to walk. We know this because an earlier version of this robot, using the same technique, learned to walk after 100 hours. But walking won't, by default, lead to robotic consciousness. And that's why self-awareness is so crucial.
This is a robot which we've taken to calling a self-aware robot. It is self-aware pretty much in a literal sense that it is aware of itself, its locations in space, and its dynamics as to how it moves.
Okay, so it kind of understands its own movements and where it is in space. How does it do that?
By leveraging this technique, which has become popular in recent years, called deep learning.
Deep learning is a form of artificial intelligence that, like the human brain, learns through raw data, unsupervised and without structure. Deep learning gives machines the ability to experience and process reality, like us. Rob has devised an experiment to test what this robot knows about its world.
You could think of it as if you're looking at these red cotton balls. You have some idea in space as to where they are.
Right.
Now, if you were to close your eyes and try to pick them up and put them in this cup. So obviously it's not a trivial task.
No.
But it's not the most difficult task in the world because we have a good proprioception. We have this good model of yourself. You know where your arm is in space relative to other things that you see in space.
But for this robot, there's a catch.
So where are the cameras?
So there's no camera. It's
None.
as
No,
if
no,
you were to close your eyes, you know the locations at the start, and it's picking it up and placing it completely blind.
Furthermore, it was not given a map or any formal instructions. The robot simply has to feel its way through the task.
All right, let's see it.
Give it a shot.
First, the robot learned how to use its arm through trial and error, developing a sense of proprioception. By exploring its surroundings, it generated an internal representation of the world and its place in it. The robot is using only its internal image of the external world to maneuver its arm to pick up all 9 balls and place them in the cup. I'm not sure that's something I could do with my eyes closed.
Huh. It's really just based off of understanding where you are in space.
Yeah, that's right.
Creating AI robots that have an internal model of their world is an important step towards machine self-awareness.
Self-awareness is sort of a similar proprioceptive capability, but applied to mental thinking. So if they think about thinking, they think about what they are, because once you can do that, it means you can plan things into the future.
Once robots become self-aware, they will need advanced ways to communicate with humans. Keyboards and screens are inadequate for complex thoughts. Robots will need to learn to speak and have natural conversations, like a baby who listens to those around her and learns to talk. Laying the groundwork for this kind of human-machine interaction is pioneering scientist Barbara Gross of Harvard University. Her seminal work in what's called natural language processing directly led to the development of voice-activated artificial intelligence. You know, like Alexa or Siri.
Natural language processing actually predates artificial intelligence and started with machine translation efforts.
The ability for a computer system to carry on a spoken dialogue with a person has been a long-standing goal of artificial intelligence research from its inception.
And it turns out this is a challenge because when you speak, what you say really depends on the context in which you say it.
Another challenge is the meaning of words can change depending on how they are delivered.
So one example is the contrast between saying, "That's fabulous," and "That's fabulous." Also, when we have a conversation, we mark paragraphs at the beginning with a rise in intonation and a fall at the end. So there's a whole way the speech signal tells you something about the context and something about the intended meaning.
Barbara's early research led to methods for programming computers to understand the meaning of spoken language by using clues from a person's tone and context.
So let's flash forward. The speech systems are amazing now because there are lots of recordings of people speaking that they can build their systems on.
As a result, AI has gotten much better at understanding what people say. However, there is still room for improvement.
The systems that do exist are pretty much focused on very narrow tasks. Let's take Siri and Alexa as examples. They're mostly oriented around a single question or a single request. And they presume that anybody will stay within the range of behavior that the designers imagined.
So, researchers are turning to machine learning. By training AI with hours and hours of human conversation, they can learn to better understand the context of how humans converse. Future versions of this technology will allow us to have natural conversations with our computers.
One of the things that's amazing to me is that the fields have succeeded so well that there are devices out in the world that people use every day. I never dreamed that would be the case in my lifetime.
Hyper-intelligent natural language AI will change the way we interact with our computers and robots. But this advanced technology will never reach its full potential as human companions until it looks convincingly like us. I'm in Los Angeles to meet Hao Li. His company Pinscreen is giving AI a human face. They're developing cutting-edge techniques to create hyper-realistic digital avatars in an instant.
One of the hardest things to bring to the virtual world are humans, right? And specifically faces.
To create believable faces, Hao is relying on complex AI algorithms.
It's an artificial intelligence that actually digitizes yourself into the computer by just looking at a single image or partial information. And it's not just a 3D model, a static one, but it's one that can also be animated and brought to life.
Other methods of generating lifelike avatars need to capture multiple angles of a face in motion, and they can take hours to render, but not Pinscreen's technology.
I can show you real quick how this works. Do you want to see?
Yeah. Incredibly, his software also allows him to superimpose any face he wants in real time.
So if I do this blue face is basically a face tracker. So in real time, it's actually modeling my face in 3D. So if I move around my face, the blue mask is basically a three-dimensional representation of my face.
Wow. It's kind of like a green screen.
Sort of like, right?
Like a Hollywood CGI film, the computer dynamically models Hao's face and tracks his movement on the fly.
Click on him, turn myself into Putin.
Wow.
Right? And it's basically generating the whole thing in real time right now.
Oh my gosh. I feel like Putin's talking to me right now.
Political leaders aren't the only thing Hao can generate.
You're gonna be Tom Cruise. This is Audrey Hepburn.
Oh wow. Look at you. You're so pretty.
It's generating all the pixels in real time. These teeth are never seen in this picture.
So it's predicting what your teeth would end up looking like? These aren't even your teeth.
Yeah, these are not my teeth. It's actually generating.
Oh my goodness.
Hao believes that software like this will give a more human face to the digital world. Ultimately, this will result in friendlier-looking androids and even virtual beings.
I have been hanging with my dog for a while. Do you have pets?
I have 3 toy poodles. Someday, we're actually going to interact with virtual beings that are going to assist us in our life. Imagine instead of talking to Siri or Alexa, you're talking to a face, right? And it's the best way to communicate is to have a face-to-face communication. And AI provides you perfect companionship.
This kind of technology will give AI a face that most people can relate to.
Are you human or are you artificial intelligence?
That is a very interesting question. I think I am human, but I am artificial intelligence.
Hyper-intelligent companions could usher in a more helpful and hopeful world.
In the future, AI-powered virtual beings that look, talk, and even think like real humans are commonplace. These holographic assistants take care of many aspects of daily life, ranging from fashion advice to business consultation. Their faces and wardrobes can be customized depending on their role. When a doctor is required, these virtual assistants play the part and are always on call. Armed with the latest medical knowledge, they accurately diagnose most common diseases. The same technology is also capable of capturing the image, voice, and life story of loved ones. After death, these virtual friends and family are always a part of our lives.
Even if engineers can create lifelike robots that look like humans, called androids, in order for AI to become true companions, people will need to feel comfortable embracing these androids figuratively and literally. I'm outside San Diego to meet Matt McMullen, the founder of Realbotics. Matt is building androids that people will want to embrace, physically.
The goal is to create not only a robot, but an AI that are both appealing enough that someone would feel like they were actually getting to know someone not something.
Once the sculpting and casting is complete, members of Matt's team mold the silicone skin on an actual functioning robot.
The faces are actually modular. The face just literally comes off.
Yes, it does.
The idea is you create one robotic head and a whole bunch of different characters that can all run on that same head. So all of the things that move in the face are actuated by these magnets that are in the skin.
Matt's team of programmers use artificial intelligence to create advanced chatbots for these robots. The goal is for them to have natural conversations with their companions.
It's blinking.
Yeah, she's a blinker.
This is a test of my system.
Oh my gosh, it's looking at me.
Hello, how are you today?
I'm okay. I'm fine. I'm doing just fine. How are you?
Why do you ask me that?
You know, because I care about your feelings.
Speech is only one aspect of human communication. Facial expressions are hugely important in social interaction. So Matt is incorporating this non-verbal communication into his androids.
The vision system that we're working on, she'll be able to look at you and detect your emotion by the expression on your face, by the temperature of your skin, and all these other things.
Communication verbally and non-verbally, or is key. Right?
Yes, exactly. It looks remarkable. It's moving, it's talking, and it's having this dynamic conversation with you. That's the wonder.
I can imagine some people might walk in here and say, oh, look, a sex robot.
The thing is, to make a really impressive and good sex robot, you actually have to make a good robot in the first place. But I think that the longer term goals are going to be to create these systems for people to use in whatever way they see fit.
Matt is building these androids for a wide range of applications.
We're creating human-like robots that we think can be used for a huge variety of things. For people who are lonely, whether they're old or maybe they're socially isolated, or maybe they suffer from social anxiety.
Androids with a friendly face could keep the elderly company and monitor their health. Armed with artificial intelligence, these androids could take on other qualitative roles.
I think therapy is a huge one. Using the robot as a safe conduit for communication and letting people really open up because they don't feel like they're being judged by something like this.
Yeah. Companion androids like this will forge a future where nobody will ever have to feel alone again. While lifelike human androids and virtual beings have the potential to enhance human social interactions, there are ethical concerns as well. Using artificial intelligence, it's possible to hijack a person's physical identity.
There is one very big problem in the whole thing, which is privacy. What if I would do something harmful to you?
And when you say harmful, you mean reconstruct somebody and have them say something that they would never say or never do.
Right.
Digital fabrications like this are already emerging online in what are called deepfakes.
I can go on your website, take a picture from it, and then create some content with it without your consent.
Also dangerous, swarms of AI-driven drones could be used in terrorist attacks.
Can drones be weaponized? Of course they can be weaponized. These scientific breakthroughs yield results that can oftentimes be used against humans. So you have to be held accountable for what you developed, and it's a moral responsibility to think about the broader consequences.
When it comes to ethical considerations like these, I still feel hopeful that science, technology, and human ingenuity will find solutions to these big problems.
The potential for artificial intelligence to profoundly improve society, to improve jobs, to improve healthcare, to improve education is enormous if we do it the right way, trying to build computer systems that assist them in doing what they're doing better.
Technology is more likely to provide some tools that will allow us to become superhuman, augment our intelligence, to make better decisions and to get better insights about the world.
Future versions of this technology will become even more intelligent than us humans.
I believe There's no doubt robots will exceed human capability. I mean, the path is very clear. Whether it's going to take 20 years or 200 years, this is maybe the most powerful technology we've ever invented.
The potential of AI is limitless. Whatever big idea you can think of, you can ultimately probably program a robot or a computer to carry out your vision.
And in the right hands, this technology has the potential to radically transform every part of daily life for the better. A true partnership with hyper-intelligent robots, with their intentions aligned with our own, will transform humanity for the greater good.
This is what the road to human immortality looks like. To battle aging, people receive customized fountain of youth treatments, DNA repair, cellular rejuvenation, or even organ replacement. The realistic prospect of healthy, eternal life is fundamentally reshaping society.
Ooh, this I want to try. Today, scientists are blazing a trail to this very future.
We are at war with death.
I want to know what breakthroughs are being made.
We can build an organ that matches your body.
This cocktail seems to reverse aging.
That will forge the future to so complex. Human immortality. My name is Maren Hunsberger. I'm a microbiologist, and I'm fascinated by how the future inspires the progress of science and technology. But I'm critical of sensational science headlines that promise immortality. Still, all of these stories have prompted me to ask, how quickly am I aging? To find out, I recently took a blood test. I mailed it off, and now the results have just come in.
I, in real life, am 26, and we're about to see what this biological aging test says I am. So, my biological age, according to this test, is 40.
Learning my body has aged 14 years faster than expected is not the result I was hoping for, but it makes sense. My life partner was recently diagnosed with cancer, and I guess that stress has clearly taken a toll. While I have some doubts about the accuracy of this particular test, I am concerned that stress could further affect my health in the future. So I want to find out, is it scientifically possible to slow or even stop the aging process altogether? If so, what will our lives be like in the future? Hello, we're in Vegas. To find out, I'm attending RadFest, where a group of experts are gathering to put an end to old age. This event bills itself as the Woodstock of radical life extension.
We want to create a mass movement to save lives.
I'm immediately struck by the extremely bold claims of healing and even immortality.
We're immortalists. We're into immortality. That's what we're about. you're doing really good and life is great, you're gonna wanna keep on going. So what do you think?
Festival director James Stroll calls himself an anti-death activist.
I want to live indefinite lifespans. That's what I'm after. I want to live forever. That's my goal, okay? I personally think it's better to go for it and lose than not try at all, right?
Sure. What perceptions about aging and death in the public are you hoping to change? Like, what would you want people to take away from it?
Most people are pretty much, I'll use the term programmed, that death is inevitable. And we want to change that paradigm. We see aging as a disease, a curable disease. And we're at war with death.
The idea that aging might be cured like a disease is relatively new. But this yearning for eternal youth goes back thousands of years. Cleopatra supposedly bathed in sour donkey's milk to make her skin appear more youthful. And since then, people have tried using everything from raw meat to guinea pig testicles and even menstrual blood to combat the aging process. Blood appears to be a recurring theme in this quest for immortality. Some ultra-wealthy patients are trying a controversial new therapy. They're receiving transfusions of blood products taken from teenagers in the hopes of rewinding their biological clocks. So far, this process has yielded no measurable benefits. There are dozens of therapies available at the Radfest marketplace. I'm wondering, are there claims based on sound science?
Ooh, this I want to try.
This procedure claims to boost a person's energy at the cellular level while reducing stress and anxiety.
How does the red light rejuvenate my mitochondria?
A lot of the research looks at decreasing the inflammation, improving the blood flow.
This treatment is supposed to boost the immune system.
These machines are hydrogen inhalation devices.
What's the hydrogen supposed to do?
So it's basically a master antioxidant and anti-inflammatory.
This device promises to relieve pain throughout the entire body.
So this is the Avicin.
Uh-huh.
What this does is it infuses heat throughout your circulatory system.
Just by delivering heat to my hand?
Yes. And they also have done research in the diabetes arena, cardiovascular, and also autism.
The spiel that they have contains a lot of scientific words peppered in there, which are legitimate scientific words that refer to a real phenomenon. But it plays into this idea that anything that sounds science-y is true and that you should believe it and trust it. But that does not mean that their product is going to make you live longer.
Though I'm sympathetic to the anti-aging cause for very personal reasons, from a scientific point of view, I don't think the remedies on display here will lead us down the path toward immortality in the future. To find a more realistic path, I'm at the Massachusetts Institute of Technology to meet a pioneer in longevity research, Dr. Leonard Guarente. He's taking on a big problem that most everyone will eventually face.
As you get older, you lose muscle mass and you gain fat mass.
Okay.
And both of those things are bad.
Sure.
Lenny is a firm believer in the power of exercise to keep our bodies healthier for longer.
By impacting aging, you can not only improve health, but help mitigate diseases.
At his cutting-edge lab, his team identified the first longevity gene. And this breakthrough opened the door to the possibility that we might one day control the aging process in living organisms.
I think the best case scenario is attempting really to maintain what we call health span. If people live healthier lives for as long as possible and really compress morbidity to a very short period at the end of life. That's my goal.
Instead of slowly declining in our 60s, plagued by things like heart disease, dementia, and cancer, Lenny thinks we could live until 90 and then make a fast and relatively peaceful decline into death. To make this a reality, Lenny is combating the aging process at the cellular level.
So I'd love to walk through the molecular, cellular basis of aging and what's happening in our cells as we age.
Okay.
Yeah.
Let me draw a cell.
Okay.
So there's the cell, mitochondria. They produce the energy. This will be the nucleus here.
Okay.
chromosome in the DNA.
DNA contains all of the information for maintaining cells and building new ones, and those cells are busy dividing. But here's the problem for achieving immortality. Cells have a kind of internal time limit. After about 50 replications, they can't divide anymore. This roadblock is known as the Hayflick limit. On top of that, as a person's cells divide, they also accumulate damage and release toxic waste byproducts. As these toxins build up over time, the affected cells gradually lose their ability to function. This is the aging process at the cellular level.
That's the important thing about living critters is we do have things break down, but we also have the ability to repair damage.
Sure.
In principle, the goal would be to boost the ability to repair the damage.
To capitalize on this process of regeneration, Lenny and his team targeted a gene in live roundworms called SIR2. SIR2 genes create proteins called sirtuins. These sirtuins coordinate the cell's response to stress, including repairing DNA damage, which can slow the aging process.
Oh my God.
They're alive. They
Yeah.
should be moving.
Oh yeah, they're moving around. They look like little threads.
So we first looked at the roundworms, and we found that, yes, the worm's SIR2 gene was involved in aging. And so by extension, then, we think this is going to be true universally. And there's tremendous amount of evidence now that shows that these sirtuins regulate aging.
By inserting extra copies of the SIR2 gene into the worm, Lenny and his colleagues can interrupt the aging process and increase the lifespan of a worm by 50%. That's the equivalent of increasing the global average human lifespan from 72 to 108.
What we know about sirtuins is that we can intervene and make people healthy for a decade longer than they are now.
Lenny has found a fascinating connection between these genes and the body's natural survival mechanisms. And it upturns many of our assumptions. Studies of mice and rhesus monkeys suggest that the production of sirtuins increases in times of stress, including when food is scarce.
Animals on a very low-calorie diet age more slowly.
That's so insane to me.
That means you can identify compounds that increase the activity of sirtuins, that mimic what calorie restriction would normally do.
Right, so
What a-
you don't actually have to calorie
Exactly.
restrict.
This process gives all the health benefits of a low-calorie diet without going hungry. Lenny wants to apply this discovery to everyone. He is now testing a new dietary supplement to increase the activity of sirtuins in humans.
So that's one of those rare moments where in an instant you have something that you know is going to be big.
That was kind of, I believe, was the aha moment. That's really the only time I've ever experienced something like that.
Wow.
By pushing the limits at the cellular level, Lenny's research could forge a future path toward human immortality.
In the future, a high-tech procedure optimizes health spans. The treatment stimulates longevity genes and mimics full-body calorie restriction. This regular toxin cleanse and cellular rejuvenation extends lifelong health to averages well past 125.
Even if scientists can slow aging like this, how will it actually feel physically to grow this old? Over at the MIT Age Lab, Samantha Brady is exploring the impact of extended longevity on the function of the human body.
We are in this unprecedented time of longevity. Back in the 1900s, average lifespan for people was about late 40s.
Seriously?
So that's crazy to think
I
about.
did not know that.
Everyone is living longer lives thanks to advances like greater access to clean water, antibiotics, and vaccines.
Now we have about a 30-year bonus.
But it's not all rosy. Sam helped develop a suit that, well, simulates what my body might feel like at upwards of 70.
So we're gonna start with this weighted vest.
Okay.
This is one of the pieces that's gonna help simulate what muscle loss might feel like.
Okay.
We'll just strap you in.
This suit mimics the shortening of our ligaments.
Oh my God, they're heavy.
Spinal compression, and the loss of balance that occurs as the years go by.
Let's pop the goggles on.
It also simulates loss of vision and hearing.
You are now Agnes.
Transformation complete. I definitely feel like a different person.
I always imagine myself enjoying my life as I get older.
Give it a shot.
That's about as far as I can go.
But it's pretty hard to do anything in this suit.
Whew. Yeah, that's rough. I can get my knees a couple of inches off the floor and that's it.
Now, I'm worried that as I age, I won't be able to do the things I love anymore.
So it looks like this is pretty tiring already with just the couple moves
totally
that you did.
Exhausted.
And I keep thinking about the results from my biological aging test, which mean this could be a reality for me sooner than expected. It's actually pretty terrifying.
Can't wait till I can take it off. And then imagining, like, there are some people who can't take it off.
This is clearly not how people want to feel when they are 100, 150, or ever. The decline of muscles and the skeletal system is just the tip of the iceberg. As cells stop dividing, they accumulate damage, which ultimately can cause tissue and organs to fail. In the heart, this means valves and the muscle itself can become thicker and stiffen, reducing blood flow. Incredibly, heart disease is actually the #1 cause of death around the world. And to combat organ failure like this, scientists are working around the clock to find unique solutions. I'm in Houston, Texas, to meet a scientist who could revolutionize the way we source organs for transplants.
She's often been called the Dr. Frankenstein of this area, and so I am bringing her a little gift.
Dr. Doris Taylor is growing hearts in the lab. And she's closer than ever to making lab-grown organ transplants for humans a reality.
I have a gift for you.
Oh, I don't normally get a heart as a gift. How cool is that? We call these our ghost hearts.
Ghost hearts?
It's amazing to see the engineered organs up close.
This is a rabbit heart, and it's about the size of a pediatric newborn human heart.
Oh, wow. Doris, can you tell me how you got into a field like this?
I wanted to make a difference in the world. My twin brother was sick his entire life, and then when I was 6, my dad died. It motivates me when I think about that feeling of helplessness to want to make a difference in the lives of people with disease.
Because people are living longer with heart disease, many people develop heart failure. The only definitive cure for heart failure is a heart transplant.
Every 10 minutes, a new person goes on the organ transplant waiting list. So clearly, people don't get the organs they need. We can change that. We can build an organ that matches your body, and you can live longer and live healthier.
The first step Doris takes in building a new heart is to strip the tissue and cells from an animal heart using a wash of detergents. What remains is effectively the protein scaffolding of a heart.
If you look at this is the pig heart that we've washed all the blood out of.
It's so complex.
It's beautiful.
It is.
It's beautiful. It's humbling. You're holding an organ.
The next step is to grow a new human heart on top of this animal scaffolding. Doris does this by recellularizing the organ with human stem cells.
Stem cells are cells that are found in every organ or tissue. We all have stem cells. They're cells that respond to their environment and become like the cells that surround them.
Certain types of stem cells can transform into any kind of cell, from blood to liver to heart. Key to the process, these stem cells replicate much more than regular cells. This allows them to grow and cover the heart scaffolding very quickly.
This is one of the rabbit hearts that we've put cells in.
Oh my gosh, it's in there.
You can see that we're getting electrical activity here from.
So this is like an
it.
EKG
So this is
for
an
that
EKG, yeah.
heart in there. The EKG machine, or electrocardiogram, measures the electrical activity of a beating heart. So one thing is clear, it's alive. I can see it moving. Doris believes that her technique for building implantable hearts could be used to grow other organs as well.
I truly believe if we can go to Mars, we're going to Mars in the lab. We got the rocket ship, the scaffold.
Yeah.
We've put the astronauts on board, the cells.
Yep.
And now we just got to prove it's
Blast
safe.
off. You guys are getting there.
Yeah.
And within a decade, she thinks she'll be able to surgically implant lab-grown organs like these for people in need. I find this hugely moving.
I had a patient say, you're not building organs, you're building hope.
This is a path to the future I think we can all hope for.
In the future, body part farms exist in most hospitals on Earth. Organs and limbs can be 3D printed to order. But for emergencies, prefabricated organs are available in all blood types and body sizes. With the assistance of robotic surgeons, body parts can be replaced in under 8 minutes. Severe accidents and injuries are no longer fatal.
In my quest to unravel the mystery of the aging process, I'm finding that, like me, many scientists are doing this for personal reasons. Earlier this year, my partner was diagnosed with Burkitt's lymphoma, and it's the fastest growing human cancer. We just had to think so much more about the end of our lives in a way that you don't have to usually until you're well into the later part of your life. To find a pathway that will lead us toward longer and healthier lives, researchers are going deep into the jungle and to the bottom of the ocean. There, scientists have found that bowhead whales and Greenland sharks can live well over 200 years, while killer whales live no more than 50. What makes some creatures live longer than others? To find out, I'm at an aquarium in Las Vegas to talk with the legendary gerontologist Aubrey de Grey about another long-lived sea creature, the lobster.
The big thing that's special about lobsters is that they live a really long time. There are now reports of lobsters having lived longer than any human has lived, which is 122 years.
Incredibly, this crustacean doesn't age, at least not in the way humans do.
The other thing that lobsters have, the really big thing they have, is they grow and grow and grow as long as they live.
Unlike humans, a lobster's cells never stop dividing, so this creature never stops growing. They may die due to predation or disease, but not old age. Why does the lobster live so long? The answer can be found in something called telomeres. Humans also have telomeres. Telomeres are repeating sequences of DNA at the ends of chromosomes. If chromosomes were shoelaces, then telomeres would be the little protective caps at the tips. These caps protect DNA during cell division. But as our cells divide throughout our lifetime, these telomeres gradually shorten. When the telomeres become too short, the cell stops dividing and eventually dies. However, there is an enzyme called telomerase that helps maintain these protective caps. Incredibly, lobster telomeres do not appear to get shorter over time. Many believe this protective enzyme is the secret to their long lifespan. Scientists are currently devising telomerase treatments to try and produce the same life-extending effect in humans.
What do you think a child born today, how long could they possibly live?
So really there is no limit to how long someone can live.
Aubrey tells me that a child born today could benefit from constant scientific breakthroughs. A treatment at 80 years old might allow them to live to 130, and future treatments could allow them to extend their lives potentially for forever.
That means that the only limit to longevity is causes of death that do not have to do with how long ago one was born. You know, being hit by trucks.
Bolstering telomeres isn't the only way to extend human life at the cellular level. At his lab in California, Aubrey is advancing the science of anti-aging in another area. He believes that a lot of the problems associated with aging happen when cells become what's called senescent. They don't divide anymore, but they don't go away either.
Some people call them zombie cells, you know, essentially undead. They're secreting nasty chemicals that are toxic to their neighbors and so on, but they're not dying.
So one of the most key developments, in your opinion, you think, is in essence, getting cells to be better at taking their own trash out.
Oh, yeah.
Using gene therapies, Aubrey believes removing these zombie-like senescent cells will radically extend our lives.
It turns out that we were able to exploit some really great technology that was developed for a completely different reason, the technology of what's called bioremediation, which is used in environmental decontamination.
To clean up pollutants.
That's right.
And they eat up the oil or the chemical or whatever it may be.
So we do the same thing. We identify bacteria that are able to break down the thing that we're interested in. We identify the genes that they have that allow them to have this capacity, and we put those genes into our own cell.
By inserting these new bacterial genes, our bodies might be able to eliminate these zombie senescent cells.
Most people didn't take me seriously at all at first.
Interesting.
But now this is a totally mainstream idea.
While some remain skeptical of Aubrey's approach, a handful of biotech companies are also taking aim at senescent cells.
I've never thought of aging and death as anything but inevitable, so to think of that not happening, I think really upends my worldview.
In the future, a revolutionary new treatment to destroy zombie cells is extending human life across the planet. While resting in an oxygen-filled chamber, individuals are injected with thousands of miniature robots smaller than red blood cells. This army of nanobots scour the body to hunt down and destroy every last toxic senescent cell. One treatment every year starting at age 20 extends most human lives by 50%.
Living to 200 years of age or more may seem like science fiction, and the big challenge in making it science fact lies in getting these practices to work not just in lab animals, but in humans. In Indiana, one community has already made steps toward hacking the aging code without even knowing it. Dr. Doug Vaughn of Northwestern University has identified a unique and isolated group of people, many of whom are living dramatically longer than average lives. And it's not who you might expect.
There is a large, old order Amish community here that settled this region in the early 1800s.
From Switzerland,
From
right?
Switzerland, yeah. They're living a lifestyle that's very, very homogenous.
The Amish avoid modern technology and farm using the same traditional tools as their ancestors.
We brought 200 members of the community into this center, and over 2 days, extensively studied them, did all kinds of things to measure their biological age as opposed to their chronological age. Took blood samples, measured their blood pressure, measured their telomere length.
For Doug, the results are astonishing.
At multiple levels, it looks like some are protected from aging. Their telomeres are longer, about 10% longer. They also have a more juvenile cardiovascular system. They're completely protected from diabetes, which is rather remarkable. That might have been the most striking finding in our studies because insulin is thought to be a driver of aging and aging-like pathologies.
What is their secret to a long life? Is it family history? The Amish lifestyle? One member of the Amish community, Neville, has agreed to talk to me. But for cultural reasons, he's asked that we don't show his face.
So it seems peaceful too and restful.
Yeah, it does get stressful some days, trust me.
I could.
This is my horse. Her name is Bee.
Hi, Bee.
And she's our source of transportation.
His family's lifespans are especially impressive when measured up to the average global lifespan, which is 72.
I understand you had some long-lived family members back in your family tree. Who were they?
One was my great-grandfather. He lived to be 92 years old.
Wow.
And my grandmother lived to be 86.
Wow.
My great-grandfather had some brothers that lived to be over 100.
Wow.
Yeah.
I can only wonder why this is the case.
Can you tell me a little more about your lifestyle?
We like to keep it simple, try to be as self-sufficient as possible, try to raise our own food from the garden. We're just people like you are, you know, so I kind of think that it just depends on what cards get dealt to your hand.
And it turns out Neville is right. Some in this community have won the genetic lottery. Doug's research is revealing what that is.
Good afternoon, I'm Dr. Vaughn.
The first clues to the Amish community's longevity recently surfaced when a member with a particular blood disorder visited a modern clinic.
Do you have any family members that have that bleeding problem that's present in some of the community around here?
My dad, I think he's a carrier, but none of us is bleeder.
This bleeding disorder is the result of a genetic variation that isn't found anywhere else in the world.
The original founder of the mutation married into the community in the early 1800s.
Wow.
He had 15 children and 148 grandchildren in the mid-1800s.
Wow.
Do the math.
The genetic variation in this Amish community occurs in a particular gene that creates a protein called PI1. Among other things, the PI1 protein controls the body's senescent or zombie cells. Doug's research reveals that those in the community with a single copy of the gene mutation produce more PI1 proteins than those with the bleeding disorder, but less than the general population. And they live dramatically longer lives. Why? It turns out it's all about balance.
PI1 contributes to a variety of different disease processes. It's not good to have a lot of PI1. It's not good to have no PI1. It's good to be in the Goldilocks zone and have somewhere in the middle.
Doug wants to hack the aging code by developing medication that essentially mimics this mutation and regulates the PI1 protein.
I have a collaborator now in Japan, and after screening a library of over 3 million compounds, they came up with a group of chemicals that looked like they might be candidates as PI1 inhibitors. We've used it in a variety of experimental studies around the world. It has some remarkable effects in terms of insulin resistance, even impacting on the development of arteriosclerosis or vascular stiffening, if you will.
I came into this whole adventure being pretty skeptical about a lot of it, but I think digging deeper into the biology has made me feel that we're at the beginnings of something really big here.
Exactly.
It's a lucky finding. I'd never have imagined that a self-isolated community's genetic variation would upend the way scientists think about everyone's lifespans. Blazing a trail to immortality seems more plausible than I ever imagined.
In the future, most babies are conceived through in vitro fertilization, where it's possible to slow the aging process before birth. First, parents choose from a menu of longevity genes, including the Amish variant. Technicians then customize and engineer the egg's DNA before fertilization. Through this medically regulated conception, newborns can expect to live 200 healthy years or more.
While this kind of future seems appealing, what might a healthy multi-centenarian actually look like? To get a clearer picture of this future, I'm in Los Angeles to meet Lillian Solomon. She just celebrated her 100th birthday, and by all accounts, she is the living embodiment of what all these scientists aim to achieve. She is healthy, active, and alert. She is a bowling champion and even has a new boyfriend.
I brought you a little cake for us to all share.
Oh, look at that. This is my boyfriend, Eddie.
She's 11 months older than I am.
Nice.
I like older women.
I have arthritis, and I have all the aches and pains that elderly people get, but somehow it just doesn't seem as bad. I try not to let it deter me from doing what I want to do. As a matter of fact, I'd like to take you to the park and perhaps show you how I exercise.
Oh, yes, please. I need some tips.
More people are living to over 100 than ever before. While genetics and diet are important, some recent studies show other key aspects are at play as well.
On the road again.
What's the secret to staying young for your whole life?
I think really number one is attitude. I think if you have a good attitude and you think that today is going to be better than yesterday, that helps.
Recent research backs up Lillian's theory. Scientists are finding that many centenarians have a positive outlook. They are close to their family and are extroverted.
Shut up.
And to this list, one study even adds this trait, being stubborn.
Shall we?
Okay.
What do we got in here?
Well, I do these.
Nice. Keep your arms strong. Cillian, you're so great. What a badass, if you don't mind me saying.
I do 10 of these. I complained at first. I can't do those exercises. I don't have time. If you want to do them, you will make time.
That's good advice.
It was good advice.
Lillian, you've inspired me. I was just blown away by Lillian in total, especially in her convertible.
Seeing Lillian with her boyfriend also made me think about my own relationship with my partner. We recently had the hopeful news that his cancer is in remission. This turn of events makes me so thankful for the medical advances of today. But still, I want our lives to continue to be happy and healthy for as long as possible. It makes me wonder, is there actually a way to stop growing old? It turns out there's one scientist who's working to truly understand the biological clock and actually reverse the aging process.
Thank you so much for meeting with me here at the Fountain of Youth.
Dr. Steve Horvath of UCLA is a biostatistician who's invented an intriguing tool that could help us find a way to roll back the biological clock. Steve created a blood test to determine biological age. It's widely considered to be the most accurate in the world.
So Dr. Horvath, why is it important to have a test like that?
Imagine we want to prove that this is the fountain of youth, right? Somebody would have to dive into here. We do a before and after measurement, you know? We would want to convince ourselves that it actually rejuvenated the epigenetic age of that person.
So it's really useful to have this clock as the metric to use if you're thinking of a treatment.
It's essential. A test for biological aging is really quintessential in order to distinguish snake oil from therapies that actually have an effect.
Dr. Horvath's blood test measures something called DNA methylation. Methylation is a process that regulates how genes function. Methyl groups get added to DNA as we age, kind of like rust on metal. Using his test, Steve has worked out the average rate that this methylation happens throughout people's lives.
By looking at this methylation change at several hundred locations on our DNA, we can very accurately measure the age of the tissue. Some people inherit good genes, and their epigenetic clock simply ticks more slowly. Example are centenarians. We analyzed blood samples from centenarians and their children, and sure enough, it was younger than expected.
They got lucky.
Dr. Horvath collaborated with a team to see if they could replicate this effect with a drug therapy. Over the course of 12 months, 9 men took a diabetes drug known as metformin, along with 2 other kinds of hormones. Steve tested the men's biological age both before and after the trial, and received some surprising results.
When I first ran the statistical analysis on my computer, I was really blown away. I couldn't believe my eyes. This cocktail even seems to reverse aging.
By how many years?
By roughly 2.5 years.
In effect, this mix of medications reverses that rusting of people's DNA, leading to visible changes in the body.
There was one gentleman whose hair was entirely gray, and after the treatment, it was darker again. There was repigmentation. If we are really lucky, maybe this treatment, this cocktail, really has a holistic effect. It affects many organs of your body. But first, this treatment has to be carefully evaluated and replicated.
Well, that's what makes me trust you, Dr. Horvath.
Although this study was very small, the promise of reversing the course of aging cannot be underestimated.
It's my dream that people get an annual measurement of their methylation. And then the doctor would say, you know what, you age a little bit too fast. Why don't you take this anti-aging treatment?
And do you think that could extend people's lifetimes to a healthy 100 years?
I am quite convinced that people live till 150. The question is only when.
With Dr. Horvath's approach added to the mix, I can more clearly see a path toward a future of extended life.
In the future, an age-reducing DNA cleanse comes in a simple pill. Taken yearly by people over 50, this therapy scrubs the methylation rust and rejuvenates the whole body at the cellular level. Most people's genetic codes can now be reformulated to the 97th percentile of optimal health. Whether 50, 150, or 200 years old, it's possible to feel like you have the body of someone in their 30s.
As a scientist, I'm excited about these breakthroughs and the future that science is promising us. But as a human being, there are questions outside the laboratory that seem equally important to me. It seems that on many levels, our limited lifespan has defined who we are as humans. And I wonder how we'd change if we all live until 150 or even longer. Just because we can extend our lifespan, should we? And who will benefit from these treatments? Will only the privileged benefit from this extended life? When it comes to life expectancy in the future, it makes me wonder how class, race, and geography might play an even greater role than they already do. And how will the planet cope with human immortality? We're already struggling with overpopulation and resource depletion. But I do feel hopeful that science, technology, and pure human ingenuity can find solutions to these admittedly enormous problems.
I think by 2050, we'll probably have human beings that regularly make it to 120. I'm almost certain we're going to have individuals that live to ages that we've never seen before.
I want to make sure that no parent or no child has to lose someone they love.
There are always unexpected developments that nobody has foreseen. So there are these breakthroughs suddenly. And if we get lucky, we will be able to reverse the ages of people.
While developments in science are making extended human life an increasingly real possibility, it's clear that there are things we can all be doing today that may help slow the aging process, like exercising, following a balanced diet, and even simply just keeping a positive outlook. I'm heading back to the lab too, where, as a microbiologist, I hope in some small way I can also contribute to all of us leading happier and healthier lives.
Oh man, if I could live like Lillian, I would live to 100. If I could live like Lillian to 120, I would live to 120. I don't think we can predict the effects of what's going to happen to our world as a whole as we all live longer lives, but I'm pretty excited to find out.
This is what the future of life off the Earth looks like. The Moon is a fully developed commercial hub and way station for traveling deeper into space. Anyone who wants a truly out-of-this-world vacation destination can now look to the stars and back down at Earth. The first permanent settlers of Mars arrive to self-building habitats that produce air, water, and food. With a new generation destined to be born on alien planets, this is the next step in our evolution as a species.
Well, this is the coolest thing I've done in a long, long time.
Today, scientists are blazing a trail to this very future.
This is just a remarkable structure from an engineering perspective.
I want to know what breakthroughs are being made.
Water could be used as rocket fuel, so we could use the moon as a refueling station.
That is a big, hairy, audacious goal.
That will forge a future to, here we go, life off Earth. My name is Justin Schaefer, and I'm an environmental scientist. Since I was a kid growing up on the south side of Chicago, I've always dreamed of exploring space. When it comes to the very expensive prospect of sending humans to live in space, many people ask, why should we go? But as someone that's concerned about climate change and the health of planet Earth, should we be thinking about moving to another home? If so, how will we actually build an outpost on an alien planet and then survive the lethal environment of outer space? I'm in Columbus, Ohio to meet someone who knows firsthand. Former NASA astronaut Dr. Catherine Sullivan.
Kathy was a truly inspirational figure to me. I was an intern at NOAA, the National Oceanic and Atmospheric Administration, the first time we met. It was then that I saw the possibility of being an astronaut as something that was very real.
Incredibly, this prospect seems possible in my lifetime. To find out just how and when humanity will accomplish this, I'm catching up with Catherine, my old mentor.
I just remember listening to you speak. It made me want to be an astronaut. It made me think that it was actually a feasible thing.
Well, thanks. That makes me feel really good. Welcome to our planetarium.
Whoa.
You can project things on this dome that will take you anywhere in the universe.
Catherine is a geologist, deep-sea explorer, and was the first American woman to walk in space. She knows a thing or two about life off Earth.
You spent a lot of time in space, right?
My total is like 23 days.
Catherine flew multiple shuttle missions during her 15 years at NASA.
Once you're in orbit, you have effectively no weight. To be able to sort of drift in the air like a particle of dust is pretty magical.
But space is dangerous. A vacuum devoid of atmosphere, water, and oxygen. Everything we need to survive.
Do you think the human body as is designed to tolerate space for years, decades?
There are definitely some unknowns and some ifs about that. If our bodies are not sensing a gravity field, the calcium in our bones, which gives our bones their strength, that starts to leach out.
Not only that, absent protective gear, long-term exposure to radiation damages DNA and can lead to cancer.
You can certainly lose your life in space, and you've got to be aware of that and clear-minded about the risks of it.
Much of what we know about these dangers comes from studying the long-term inhabitants of space stations orbiting Earth. NASA astronaut Scott Kelly spent nearly a year on the International Space Station, or ISS. As a result of this mission, Scott experienced cognitive decline, damage to his eyes, and even changes in his DNA. Before we can attempt to build permanent bases on the Moon or Mars, we're going to have to figure out how to protect our bodies and minds from threats like these.
It's one small step for man, one
But where there's a will, there's a way.
Mars now is, I think, like the moon was in the 1960s, a big, hairy, audacious goal. I definitely think exploring Mars and figuring out what would it take to get there, I'd love to see us do that. I think it's really wired into human nature to be exploring, to not explore our place in the cosmos, to not continue to expand our understanding at the largest scale of where we live and our place in the universe. I think it's just short-sighted.
3, 2, 1, 0. Liftoff. We have a liftoff.
With so many unknowns surrounding the welfare of humans in deep space, NASA is first setting its sights on a return trip to the moon. The Artemis mission, scheduled to launch by 2024, is the first step towards establishing a permanent human presence at the moon, with the ultimate goal of using it as a springboard to the Red Planet. A spacecraft orbiting the moon will serve as a hub for research on the lunar surface. The goal is to learn how to live and operate on another celestial body while proving technologies necessary for a mission to Mars. But at present, lifting people and materials above Earth's atmosphere is extremely expensive. To build a moon base, we'll need to find cheaper methods and reusable equipment. I'm in Colorado to visit Sierra Nevada Corporation, who is working with NASA on this heavy-duty problem.
Welcome to Sierra Nevada Corporation, home of Dream Chaser.
Wow, it's beautiful. John Curry is the director of the Dream Chaser project.
The Dream Chaser is a space plane, so it's just like riding on an airplane, landing horizontally on the runway. As you know, the space shuttle flew 135 missions and worked very well. What makes Dream Chaser different is that it's so much cheaper. The space shuttle was just too expensive to maintain. We're lighter weight, we're stronger than shuttle.
The Dream Chaser's clever design and carbon fiber body allows it to hold enough cargo to supply astronauts on the ISS for half a year. With innovations like these, it can be flown 15 times before maintenance, keeping costs down. The space shuttle required maintenance after each launch. With the retirement of the space shuttle in 2011, the Dream Chaser is now the only spacecraft capable of delivering people, supplies, and science experiments to the ISS, and then navigating back to Earth for a gentle runway landing. It can also perform the whole mission autonomously, without a pilot.
I believe this vehicle is going to be critical to transporting humans to and from space on a routine basis.
Sierra Nevada plans to conduct 6 ISS resupply missions by 2024. And unlike the shuttle, which launched aside 2 boosters in a fuel tank, the Dream Chaser is designed to be launched into orbit, wings folded, atop a rocket.
So what's the top speed something like this would reach?
Orbital velocity is 17,500 miles an hour.
Dream Chaser will circle the Earth 16 times a day at this speed. But when it returns and enters the atmosphere, it practically has to grind to a halt.
What's cool about this and very innovative about this design is this is called a lifting body, meaning the lift that you get from this vehicle is actually the body itself rather than the wings.
Unlike most planes, Dream Chaser's actual body, not its wings, takes the full force of the air pressure. The underside of the Dream Chaser is wide and flat, and pushes against the atmosphere to slow re-entry.
Probably the biggest risk for Dream Chaser is the entry, because you see 3,000 degrees Fahrenheit coming back through the atmosphere to get to the ground. So you got to make sure that this vehicle can survive 3,000 degrees Fahrenheit.
The Dream Chaser can land anywhere there is a 10,000-foot-long runway, which means it can return to any major airport in the world. For the Artemis moon mission, NASA is looking at a radical technology to house the astronauts: inflatable habitats. These habitats will connect to a core power module dubbed Gateway. Sierra Nevada designed a system called the Large Inflatable Fabric Environment, or LIFE, that can dock to the Gateway module.
We have a module you could actually turn into a space station, and that would be what you would want to take to the moon.
The habitat can be folded in a compact manner for launch and then later expanded in space. Once connected to NASA's Gateway module, inflatable habitats will serve as a base for researchers traveling to and from the moon.
The key elements to get us to the moon is we have to put the infrastructure in place to make sure that people can actually stay there.
Once you've got that, then you have a permanent presence in space.
Technologies like these are forging the path for humans to build a permanent home off Earth.
In the future, inflatable lunar habitats prove safe and reliable gateways to the moon's surface. On a weekly basis, researchers shuttle between the moon and Earth on advanced space planes. With enhanced rocket boosts, travel time is reduced over the 400,000 kilometer journey from 4 days to just 1. With the completion of a permanent research base on the surface of the moon, space agencies approve both the base and the orbiting station for commercial uses. Space tourists can even enjoy a one-week stay.
With inflatable habitat technology, a permanent presence on the moon might become a reality sooner than we think. But with virtually no atmosphere, further exploration of the lunar surface will require new technologies to protect explorers from the sun's lethal radiation. The last spacesuits designed to function on the moon were custom fabricated for the Apollo astronauts more than 50 years ago. These suits were both expensive and cumbersome. I'm in Brooklyn, New York to meet Ted Southern, the co-founder of Final Frontier Design. His company is developing the next generation of spacesuits designed to overcome these limitations.
Whoa, this is pretty cool.
This is where we make spacesuits. Generally doing prototyping of suits. We work with NASA and the commercial space industry to make suits work better. This is an EVA suit, extravehicular activity. So this is when you leave the vehicle. It's like a spaceship for one person.
In the days of Apollo, spacesuits were only worn for a single mission. Final Frontier is designing reusable suits that are flexible, lightweight, and durable.
Now NASA's talking about going back to the moon, but for a lot longer period of time. So they want suits that are more mobile, that won't wear you out, and that can last longer. There's no reason for a human to go to the moon or Mars unless they can get outside and walk around.
The key to surviving extreme environments like this lies in the pressurized EVA suit.
It's like wearing a basketball, which is where the challenge of like, how do you get a basketball to fit a human being and how do you get it to move like a human being?
Pressurization is essential to surviving in the vacuum of space. Without it, blood would fill with bubbles and the body would puff up to twice its size, causing death in less than 2 minutes. But pressurizing the suit to protect the wearer from the harshness of space creates a problem with agility.
So you lose a lot of dexterity.
Dexterity, tactility, range of motion, all these things are really important. We actually have a tool that allows us to test the gloves without having to put on the whole suit.
Oh, really?
Can you
Nice.
check that out?
Yeah.
Final Frontier won a prize from NASA for their superior pressurized glove design.
This is a pressure chamber, and there's a pump underneath that will pull gas out from the chamber. Stick your hands in through the ports.
The chamber is designed to create the same extreme vacuum of being in space.
You're at about 4 psi lower than ambient. You're approaching NASA's EVA spacesuit pressure.
Okay, so this is the problem that astronauts have.
Exactly.
Almost feels like I have a robot hand. Yeah.
I'd really appreciate it if you solved that Rubik's Cube, too.
Let's see. Do you think that there's anything wrong how these things should be designed for people?
Yes. Spacesuits are traditionally built like big bubbles. Theoretically, there are garments that could tighten around your body, equivalent to the gas that you're breathing, which would be much tighter fitting, potentially more mobility, that could revolutionize how spacesuits work. We're going to let air back into the chamber.
Oh, wow. That definitely changed very quickly.
But that's not the only problem they're solving. Moon dust is sharp and very fine-grained. The particles get everywhere and can cause life-threatening injury if inhaled. Final Frontier's EVA suit has a unique feature to prevent this from happening. The rear port can dock directly with a landing craft or rover.
Is this like an entrance on the backside? Is that?
That's right, yeah, you get in through the back. This will allow an interface with a suit port. so you can be inside your rover and jump in the spacesuit without bringing dust into the rover. It's also easier on the astronauts to get in and out this way. NASA's current suits, you get in through the waist, and that means you have to really contort your shoulders.
It's like a dance move, kind of.
Yeah. And there are a lot of astronaut injuries from suits, but one of the most major ones is shoulder injuries.
From getting into
the suit.
Ted's got a surprise for me. He's letting me try on the pressure suit, which is something that usually only astronauts get to experience.
Right now, we have air flowing in through the umbilicals here on your chest. The only place it will come out of is right here at your regulator. You can kind of push your head back.
With my pressure balanced, it's time to experience what walking on the moon or Mars might be like.
Try walking around in that.
I feel like I have no joints right now.
Yeah.
I'm like a tin man. Well, this is the coolest thing I've done in a long, long time. I don't know if I ever did anything cooler than this.
With advances in new flexible protective suits like these,
Okay, welcome back.
the path to exploring other planets seems clear.
In the future, EVA suits for space exploration are as flexible and comfortable as wetsuits. Skin-tight elastic undergarments apply stable mechanical pressure against the skin, eliminating the need for air pressurization. These suits also compensate for lower gravitational pull, allowing scientists to explore just as easily as they can do on Earth.
Even with protection from the harshness of space, astronauts won't survive a week on an alien planet without one living essential: water. But the cost of bringing enough liquid water from Earth to support even a small base on the Moon or Mars is astronomical. This means, if we're going to establish outposts in space, scientists must find a reliable source of water elsewhere. I'm near LA to meet Dr. Dean Bergman at Honeybee Robotics. Honeybee Robotics is developing cutting-edge tools to help NASA find and extract water on the Moon or Mars.
Nice.
Why don't we go look at some cool things?
All right.
We are developing these technologies to be able to create a sustainable civilization off of our planet. Water is the most precious resource in space just because we can use it for so much. And the more we can collect, the more ability we have to really live off-world and on other planets.
In 2009, NASA confirmed the presence of water on the Moon in the form of ice. Some estimate more than 100 million tons might be found under the surface at the Moon's South Pole. Not only will future spacefaring pioneers need this water to drink and grow food, this essential liquid has another potential important use in space. By splitting water into hydrogen and oxygen, both of these molecules could be used as propellant for spacecraft.
Water can also be used as rocket fuel, so we could use the Moon as a refueling station on the way to Mars, potentially.
Honeybee's drills were sent to Mars on multiple missions to determine what was below the surface. In 2002, the Mars Odyssey orbiter detected large amounts of water ice beneath the surface. So in 2007, NASA launched the Phoenix Mars lander to search for it.
We were part of the Phoenix mission. The idea was to uncover the ice of the poles of Mars. So we would scratch a line on the surface and uncover the ice.
Wow, well, this is a powerful thing to be in the presence of.
Yeah.
And the Phoenix mission discovered what they were looking for: the first direct evidence of frozen water on Mars. In 2018, the European Space Agency's Mars Express orbiter discovered liquid water for the first time beneath the South Pole region. So Honeybee is developing a method to extract the liquid water with this, the Trident drill with Planetary Volatiles Extractor, or PVEX. And Vince Vendiola is showing me how it works.
So this is Honeybee's large vacuum chamber. It is a 1 meter by 1 meter by 3 meter tall thermal vacuum chamber. PVEX is a coring drill with integrated heaters and electronics to be able to capture water from lunar ice.
Very cool stuff.
The large vacuum chamber is used to recreate the same low-pressure atmospheric conditions found on Mars.
So let's do a drill test. Close the chamber here.
Here we go.
I'm going to lower the foot pad onto the surface.
This hollow core drill can dig into the lunar or Martian underground and collect water ice and icy soil meters beneath the surface. What's that noise?
That percussion sound is our cam spring mechanism, which gives us an additional weight on bit.
It's kind of like a space jackhammer.
It's like a space jackhammer. And our software is designed to where we only percuss when the system detects that you're drilling into something hard, so that we save a lot of energy.
So it's taking a core sample right now?
Right, so we capture our sample force and then we activate heaters.
It's a process to extract liquid water on the Moon or Mars. First, the heaters must vaporize the ice. Then, the vapor will be collected within a cold trap and converted into solid ice for storage. Without this system, the liquid water would instantly evaporate and be lost.
Is there water in there now?
We'll see what we got.
Okay.
Open up the chamber.
The epic reveal.
Hey,
oh, nice. Nice. This is the future right here.
The red planet has plenty of ice, some buried just inches below the surface. Using this technology to extract it will make a future life off Earth possible.
In the future, advanced robotic drilling technology sets off a gold rush in space. Entrepreneurs race to prospect asteroids and comets across the solar system. Autonomous probes mine these celestial bodies for precious metals and water ice. Once the ice is converted into rocket fuel, it is more valuable than gold. Trading posts and way stations emerge across the solar system to process this precious cargo and further the exploration of space.
With a large source of water ice identified on Mars, building a long-term base there sounds more and more viable. But what other problems will scientists need to solve before people can live in a hostile environment, on missions that could stretch for years?
Yeah, we are definitely on another planet right now.
I'm in a desolate part of Wayne County, Utah. Here, it certainly looks like Mars. I'm heading to the Mars Desert Research Center to meet Commander Mark Levesque and his team.
Welcome. Let's head on upstairs.
All right. Hey, folks. Rich?
So we have a nice international crew here.
This habitat serves as an Earth analog of an early manned research base on Mars. It contains the essential components a future team would need for a long-term mission, including living quarters, greenhouse, science labs, and observatories.
There's a variety of research that goes on here: psychological, geological, astronomical.
The water-parched extremes of the Mars Desert Research Station, or MDRS, make it perfect for simulating a mission on Mars.
This is one of the closest analogs to Mars on Earth, given the landscape, given the isolation, given the sporadic communications.
At the MDRS, every effort is made to simulate the challenges of conducting research in a hostile alien environment.
Any outside activity, such as exploring the area or conducting projects out there, we have to be in spacesuits, and we have to go through a depressurization for 5 minutes in the airlock.
Science time. Okay, we're going to take 2 rovers with us, and these 2 guys are going to go in the second rover.
Roger that.
Hello, Hab. This is Ares 1. That's us entering the airlock now. Over.
Leaving the airlock. Hab, airlock is secure.
A primary scientific objective of the first research mission on Mars will be searching for signs of life, past or present. People have been preoccupied with finding life on Mars for centuries. In the 19th century, while mapping the red planet with a telescope, Italian astronomer Giovanni Schiaparelli saw what he thought to be water channels. And many believed they were artificially constructed canals built by Martians. But with the arrival of the first Mariner missions to Mars in the 60s and 70s, scientists confirmed that there was not an advanced civilization. However, recent discoveries of geological formations have excited them about the possibility that some form of life could have once existed.
All right, so we're gonna get out now. All right. So we're heading for that boulder on the second peak.
The geology surrounding the MDRS is comparable to what the first researchers on Mars will encounter.
Just want to be on the lookout for any minerals or interesting rocks that we can evaluate.
To answer the question of whether primitive forms of life existed on Mars, future researchers will look to rocks. By peering inside these rocks, they may find the presence of biomolecules or even fossils of microbes.
We're at the top of Kissing Camel Ridge. We're going to mark the spot on our GPS.
How about I can give you the grid reference now? 4249540. Over.
Yeah, this is the spot for gypsum.
Gypsum is a mineral that exists on Mars as well. In 2011, the Mars rover Opportunity discovered veins of gypsum in the rock beds. Because gypsum forms in the presence of water on Earth, scientists believe that bodies of water once flowed on the red planet. The team here in Utah is simulating this search.
We're going to keep our eyes open. When it's covered in mud, no one knows what it is.
On Earth, gypsum has a practical use. It's used in the home, in walls and plaster. On Mars, it could also be used for building new habitats.
So you'll get a lot of gypsum on these clay beds. It's just pieces of rock that push up.
Is that gypsum there?
Yeah, here's some gypsum actually. We've got a little right here. Some is nice and clear and pretty, and some is really cloudy. So we'll just mark the location on GPS and then analyze them back at the lab.
Sounds good.
By examining the gypsum and its surroundings on Mars, scientists might one day find evidence of life and prove it also evolved on the red planet. Back at the lab, the team processes and examines the stone.
Part of the interesting thing about being in the simulation is you start thinking through like, well, what would we need for this and what would we need for that? But on Mars, everything has to be either with you already or you have to like cut up cans to make it work.
Right. But I can imagine when we first visit Mars, we're gonna have to have scrappy operations like
Right.
this.
There's gonna be stuff that you're like, gonna have to make it work. And this is definitely a great practice for that.
While some team members are working out the technical challenges of life off Earth, others are studying the researchers themselves. PhD student Rich Whittle is studying how humans behave when confined for long periods of time in aerospace environments like these.
What we're looking at here in particular is the psychology of crews in isolated confined environments. We're looking at sleep quality, profile of moods, positive and negative affect.
Will being cooped up in isolation drive people crazy? Any mission to Mars would involve being away from Earth for years. A one-way trip alone takes about 8 months. And the first habitat likely wouldn't be much larger than the space capsule's tiny quarters.
So I guess this is one of the rooms, right? This is very humble.
And then this is probably the deluxe suite.
The commander suite. Oh, you can see light. This is luxury, man.
I know. I'm feeling guilty.
Mark has experienced the psychological impact of living in isolation firsthand.
I mean, Mark will spend a winter over in Antarctica.
Yeah?
At South Pole, yeah.
So it's 3 months? Or?
Oh, no, a year.
Oh, wow.
It's a challenge. You're locked in with people. You can't leave. That kind of confinement sort of forces people apart.
Towards the end, personality conflicts started to come out.
One of the longest Mars mission simulations took place in Russia. Called Mars 500, 6 volunteers were isolated for 520 days. They even simulated the up to 20-minute radio communication lag between Earth and Mars. The experiment showed that prolonged confinement led to sleep disorders, fatigue, and depression. Before the first crew can be sent to Mars for the long haul, space agencies need to figure out how to overcome the tedium, personality conflicts, and emotional toll of extended separation from loved ones.
Crews going to Mars will be training together for at least a couple of years. So they're going to work out the kinks, they're going to find out how to work together, because that's the real key in any kind of situation like this.
With Mars simulations like this, we'll definitely be able to solve the technical and psychological challenges of establishing a base on Mars and forge a path to the future of life in space.
In the future, researchers at the International Mars Base make a remarkable discovery. A particular rock specimen completely changes the way humanity thinks of its place in the universe. The sample confirms that ancient fossils similar to those found on Earth also exist on Mars. This rock reveals that the complex forces that cause life to evolve are not uncommon. In principle, life, possibly even complex and intelligent life, may have evolved across the universe.
While the first research station on Mars is likely to be small and scrappy, a long-term base with dozens or even hundreds of people will need more in the way of complex facilities and buildings. However, transporting the materials to build large-scale, heavy-duty habitats from Earth is unfeasible. How can we build a permanent outpost using what's already on the red planet? I'm in Brooklyn, New York to meet a design team with a unique solution.
So this is Mars Ice House.
That's a habitat?
That's a habitat.
Rebecca Pales-Friedman and Michael Morris run the forward-thinking firm Space Exploration Architecture. Also called SEARCH, they won NASA's International Mars Habitat Design Competition.
What we do is we design habitats for humans to be in outer space.
We use indigenous materials, materials that are native to the planet, and we create a beautiful living experience that's also functional for the astronauts.
But that's easier said than done in the red planet's lethal environment.
The primary goal will be to protect against radiation from both solar rays as well as cosmic galactic rays. The best material to protect against radiation is actually water, which makes up most of our atmosphere.
And Mars does have plenty of water ice to work with. On Earth, we're largely protected from harmful cosmic radiation thanks to our thick, oxygen-rich atmosphere and magnetic fields. But with barely any atmosphere, the surface radiation on Mars is hazardous. High-energy particles from the cosmic rays damage human DNA and can increase the risk of diseases like cancer.
So like our atmosphere protecting us here on Earth, we thought, why not build an ice house? We created this double shell structure for additive protection, but also to have a bigger space.
That is so cool.
Part of our objective was like, if we go all the way to Mars, why should we live in a cave or a concrete bunker? People should be able to look outside, look at the strangeness of the landscape, but they should also receive the daylight, which is very similar to our own here on Earth. They have 25-hour days, and they have about 50% of the light that we receive here on Earth.
But a long-term settlement will need dwellings that are more complicated than what can be built with just ice. The search team has a mind-blowing solution for that too, using the mineral-rich Martian soil, or regolith.
This is Mars X House. X House, the objective was to build with Martian regolith or concrete. We mined the exterior shell from the soil, and we mined the interior pressure bubble out of high-density polyethylene that we drew from the atmosphere. So it was like mining the sky and mining the soil to create one building.
Another crucial innovation is that this habitat is constructed before the astronauts arrive.
It's built by the time they get there, and then when they get there, they can just do the work that they need to do.
And the team has devised one far-out method for building these prefabricated dwellings remotely.
All the buildings that we've been designing are all 3D printed.
Wow. Wow, that is so cool.
Search's plan calls for construction robots to be sent to Mars in advance to build the habitats using 3D printing technology.
There are no construction workers on site. We have to anticipate everything that could possibly go wrong and design that beforehand.
But these incredible structures aren't just computer models. The design team is working with state-of-the-art 3D printers to make versions of them in real life. Using a mix of materials similar to Martian soil, the printers build actual freestanding versions of Search's structures. The future of this breakthrough technology is much closer than I could have imagined.
We'll be building a habitat on the surface of Mars by 2028.
Incredible. And so
that, I know that doesn't sound like close, but that sounds pretty close to us.
I mean, and that sounds incredible to me. So no, that's absolutely amazing.
Innovative designs using materials found on Mars will pave the way for the first settlers to arrive to move-in ready homes. But what will happen when the supplies they brought with them run out? They'll need food and oxygen to survive in this alien hostile environment. For humans to create civilizations anywhere in space, we'll need to build self-contained and self-sustaining ecosystems that work like our home planet. But how can we build water cycles and farm in desert wastelands like the Moon or Mars? I'm outside Tucson, Arizona, where researchers have been conducting decades of groundbreaking research to achieve this ambitious feat.
This is a grand experiment in earth sciences, started about 30 years ago, trying to understand how the Earth works. They decided the only way they could truly understand how the Earth controls itself is by creating a facsimile of it. This is called Biosphere 2, as we live in Biosphere 1.
Dr. Joaquin Ruiz is the director of Biosphere 2.
It almost reminds me of like a palace. Not like a laboratory or research environment, but more like a science palace. Can you tell us about what's going on here in high level?
Sure. Right in front of us is the rainforest. You have a big ocean, and then you have a desert.
It was an audacious idea. Build a small-scale version of Earth in completely closed quarters. In a matter of years, they recreated a wide array of ecosystems that originally took billions of years on Earth to evolve. To succeed, Biosphere 2 needed to be completely self-contained and sealed off with nothing brought in or taken out.
We have to recycle the nutrients. We're recycling our water, our air. We're recycling everything.
In 1991, 8 volunteers, or biospherians, lived inside Biosphere 2 for 2 full years. Like a future habitat on Mars, Biosphere 2 had to be perfectly thought out and highly engineered. The health and safety of future explorers depended on its success. Any habitat on Mars will need to remain completely sealed off from the toxic environment that surrounds it. But keeping it sealed and structurally sound is a near impossible task. Sudden changes in internal air pressure could destroy the structure itself. So, the engineers of Biosphere 2 came up with this innovative solution called the lung. And Deputy Director John Adams takes me inside.
We're going into the lung of Biosphere 2, and when it was originally constructed, they designed it to be hermetically sealed, but they knew that they had to deal with changes in pressure, and this is the device that they came up with to compensate for that.
Whoa.
This is just a remarkable structure from an engineering perspective.
I didn't expect to walk in and see this.
The lungs are connected to the rest of the biosphere by a series of tunnels to continuously balance the air pressure inside.
What we're standing inside of is an extremely large diaphragm, and that diaphragm helps to modulate pressure inside the facility. It has a counterweight, an aluminum dish, flexible rubber membrane. The combined weight of those two is 40,000 pounds. And the only thing that's keeping it up in the air as you see it right now is differential air pressure.
Wow, that is pretty insane.
This weighted rubber diaphragm regulates the 2 basic kinds of air pressure at work. As the temperature outside heats up, the air inside the biosphere warms and expands. Inside the lungs, The increasing air pressure pushes up against the weighted, flexible diaphragm. Without the diaphragm's flexibility, the air pressure would shatter the glass of the sealed habitat. In space, an incident like this would be deadly. As the air in the biosphere 2 cools and contracts at night, the weight of the diaphragm presses down. By reacting to the changing of air pressure, the biosphere 2's lungs continuously adjust, applying the right amount of force to keep the air pressure even throughout the closed system habitat.
This is where air travels back and forth as we modulate the pressure changes within the facility.
On the red planet, temperatures can fluctuate more than 100 degrees Celsius over the course of a single day, which means a feature like these lungs is essential to any future Mars habitats. And to sustain life, these habitats must cycle and recycle the air for humans to breathe, and also grow plants for food. On Earth, this process links animals and plants. Animals breathe in oxygen and breathe out carbon dioxide. Plants absorb that CO2 and discharge oxygen. In the biosphere, this fundamental cycle is recreated with the rainforest. Researcher Laura Meredith is conducting an experiment to test its resilience.
All right, so I'll show you the rainforest. So this is almost 30-year-old tropical rainforest.
This is beautiful.
Yeah, it's nice. Even 3 weeks into drought, it's pretty green. Some of the trees are dropping their leaves, the soils are drying out. But really, I think this rainforest is showing us that it has quite a bit of resilience.
In the rainforest, plants absorb humans' waste carbon dioxide the inhabitants breathe out. This subsequently helps the plants grow, and in the process also creates oxygen for the inhabitants to survive. Growing a stable, resilient plant ecosystem will be essential to the survival of any future inhabitants of the Moon or Mars. However, the first biospherians weren't so lucky. 16 months in, the oxygen levels dropped precipitously. It turns out, there was something the original designers underestimated: microbes. Microbes in the soil and in Biosphere 2's cement absorbed more oxygen and released more CO2 than originally estimated, nearly leading to disaster. Fortunately for the biospherians, they intervened and used additional machinery to pump in oxygen. In space, an oversight like this would be catastrophic, which is why it's important to simulate and fully test a system like this before building a biosphere on another planet.
Because it's a closed system, you really need to understand how your ecosystem works. Biology is really incredible in its resilience, and that's something that you would really want to have as a component of your ecosystem on another planet.
Can we create a closed living system like this one on Mars?
It's an immense challenge to put together all the complex components, but I am sure that we can create one.
Thanks to the original founder's dream, Biosphere 2 is a reality. And while this living laboratory has had many challenges, Biosphere 2 is providing crucial insights into ways humanity can build self-contained ecosystems. It's innovations like this that will forge a path to future long-term settlements on the Moon or Mars.
I think it's really going to take the entirety of society's focus for us to really start expediting the process of getting people to Mars. But I think one of the things that a few scientists brought up that I spoke with was this idea that we should focus on keeping our home here habitable and not trying to run to other places.
Some argue, why spend billions of dollars to get to Mars when we could be using this money and ingenuity to solve existing problems on Earth like poverty, disease, and climate change?
Should we flee this planet? If we can't figure out how to live wisely and live well on this planet, I think we've been given quite a treasure here in this little third rock from the sun.
But Catherine also thinks humans are destined to set foot on the red planet someday.
I think it's certainly technically possible to have a sustainable habitat on Mars, and it's conceivable that it could happen within the next couple of decades.
The technical challenges are pretty immense. It's going to take thousands of people to work on this and concentrate on it at the same time. But we feel that it's important that humans see these planets firsthand, and we'll learn more.
Others look at the greater good that can come from new breakthroughs.
It's not going to be cheap, it's going to be difficult, and we're going to need to push towards a common goal to get people to Mars, and hopefully beyond eventually. And every time we are able to accomplish something like this, we can then bring that technology back to Earth. And the more advanced these technologies get, the more advanced the technologies on Earth get. And I think that's hugely beneficial.
And the discovery of life elsewhere in the universe could have a profound impact on humanity.
I think the odds of us being the only life on the universe is very low. I think there's life somewhere, so that's again why it's critical for us to actually continue to explore, to continue to look outward, because I do think eventually we're going to find somebody else.
As a scientist that's long dreamed of exploring space, I'm excited about overcoming the challenges that will lead us to become a truly spacefaring civilization.
Getting humans on Mars and settling in a civilization, I'd love to see that in my lifetime. Will I see it in my lifetime? I'm pretty sure.
This is what a disease-free future looks like. Many people live in bio-alive habitats built from fungus and bacteria. This constant exposure to nature boosts the immune system. From birth, people use high-tech home scanners to analyze the DNA of microbes living in their guts. Armed with this data, doctors intentionally infect patients with combinations of good bacteria to keep the bad ones in check, preventing disease before it starts. By using advanced technology to adjust the microbes in everyone's body, modern diseases are mostly a thing of the past.
It all of a sudden hits you like they're inside you right now.
Today, scientists are blazing a trail to this very future.
You're actually more microbe than you're human.
I want to know what breakthroughs are being made.
Bio-augmenting our bodies will have a fundamental impact on modern-day plagues.
That will forge the future too.
To me, that was like, whoa.
A disease-free world. My name is Julia Ravey. I decided to become a neuroscientist because my nan and several great aunts developed Alzheimer's disease. This loss has made me determined to find a cure by any means. I'm fascinated by recent research that links diseases of the brain to microbes in our bodies.
And I think this is an avenue that is just coming into its own in terms of research.
Microbes are tiny living things, smaller than the eye can see. Inside the body, microbes like bacteria, parasites, and viruses can cause any number of infectious diseases. So what would happen if we just eradicated all of the body's nasty microorganisms? What would the health of society look like? To answer that, I want to understand how microorganisms cause disease in the first place. So I've come to Perth, Australia to meet Dr. Barry Marshall. Barry Barry's groundbreaking research turned the world's understanding of stomach cancer on its head and won him the Nobel Prize in Medicine.
Barry is a complete science legend.
Today, Barry is hunting a nasty microbe called Helicobacter. This bacteria infects the guts of animals and makes them sick.
There are about 30 different kinds of Helicobacter. So one of the things I'm planning to do today is go around, get some animal scat. So most of it's kangaroo.
Oh, I'm looking forward to seeing the whole process. I've never seen a kangaroo, I don't think.
Barry is trying to figure out where Helicobacter came from by searching for it in a wide range of animals.
You can see those big grassy areas over there. That's where the kangaroos might be hanging out.
Kangaroo!
So now you've seen one.
Seen one.
Well, I think I can see one.
Oh,
there,
yeah.
there. It looks like it's good enough.
By analysing kangaroo feces, Barry can get a snapshot of the microorganisms living inside these kangaroos' guts.
You get all different kinds of bacteria. We'll extract the DNA and just put all the DNA through the computer.
It was the hunt for Helicobacter that led Barry and his colleague Robin Warren to overturn what they thought might be a myth. Namely, the widely held belief in the medical community that stomach ulcers were caused by stress.
I did have patients who had ulcers, and it annoyed me that they seemed to be normal people, but when you couldn't find the cause of their ulcer, the medical books would blame it on stress. And I'd say, well, these people just seem to be normal.
When they looked at patients' stomach ulcers under the microscope, what they found was astonishing.
These bacteria were unusual. They're curved bacteria.
The infectious agent at work was Helicobacter pylori. H. pylori for short is a variation of Helicobacter that infects humans. The presence of this microbe in the human stomach upended decades of medical understanding.
All of the textbooks said that nothing can grow in our stomachs, you know, it's a sterile environment for these types of bacteria. But your findings proved otherwise.
So that became our research project. How could bacteria live in the stomach when there's so much acid? We knew these bacteria were really only human bacteria, so we had to find a human volunteer who could take the bacteria and maybe get an ulcer.
He had to prove that these bacteria could infect a healthy stomach at all costs.
So eventually I did a self-experiment. We decided that I was going to drink the bacteria, which I did. So we grew the bacteria up in meat broth, like beef soup, if you like, and I drank it down, and then I was having an endoscopy to see if they had colonised my stomach. And after 10 days, the bacteria were there, the infection was taking hold, and they were damaging the lining of the stomach.
Barry was probably the first person to be happy with this diagnosis.
I didn't have any evidence until I did that self-experiment.
Barry's experiment was a success. But how can H. pylori thrive in the stomach's extreme conditions?
We found out that Helicobacter are unique. They make ammonia and they neutralise the hydrochloric acid, so they can survive, nothing else can.
Once established in the stomach, these invasive bacteria lead to ulcers. And if allowed to fester, they can cause cancer. The question became, how could these killer microbes be stopped?
So I was excited about the fact that potentially you could cure something if it's caused by bacteria.
It turned out that antibiotics can kill H. pylori and cure the ulcers in a matter of weeks. Long before the discovery of microbes, scientists had no idea of the role microscopic germs played in human health. But in the 19th century, French scientist Louis Pasteur developed germ theory, which postulated that microorganisms cause infectious disease. And British surgeon Joseph Lister found a way to prevent germs from infecting his patients by using antiseptics to sterilise his surgical equipment and clean wounds. But the big breakthrough happened in 1928 when Scottish physician Alexander Fleming accidentally discovered penicillin. Penicillin was an immediate cure-all for scarlet fever, meningitis, and even pneumonia. This medication launched the modern era of antibiotics.
I thought it was a great kindness to be able to tell people, no, it's not stress. Take some antibiotics and you'll be cured.
Today, ulcers are no longer a chronic illness for many. And in the US, cases of stomach cancer have decreased almost every year.
Like most people, I like to prove other people are wrong. I didn't realize it was going to take 23 years before people really believed it and accepted it.
By eradicating the microbes that cause stomach ulcers and cancer, Barry's research is forging a disease-free future before infections even start.
In the future, the exterior doors of most homes have microbial scanners that detect foreign agents. When people enter the home, the scanner sweeps the entire body for harmful microbes. If detected, a home health robot immediately dispenses the appropriate medication. Most people no longer suffer from infectious disease, and doctors' visits are mostly a thing of the past.
A disease-free future like this sounds very appealing. So what would happen if we just eradicated all microbes? To find out, I first want to know exactly what functions they serve. So I've come to Amsterdam to speak with biologist and head of the Microbiome Museum, Jasper Becks. He has some sobering information about the microbe's role in the human body.
There's about 10 times more microbes in and on your body than you have body cells. So you're actually more microbe than you're human.
That is quite a scary thought. So I'm basically just a carrier for the microbe.
Micropia developed a technology to help visualize this unseen universe.
This is where you can visit your own microbes. This is you.
Hey.
You're being scanned. We're going to see who has the most microbes. So every dot that you see here is a microbe, a total of 100,000 billion of them. 99% of all those trillions of microbes live in your intestines. These are all digital dots, of course, but we also have them alive.
The staggering number of microbes on display makes my skin crawl. But there's an odd sense of beauty to behold.
When you see these under the microscope moving, it all of a sudden hits you like they're inside you right now. That is crazy.
The first person to accidentally see these tiny organisms was Antony van Leeuwenhoek in the 17th century.
He was a draper. In order to test the quality of the cotton and of the threads, he decided to build his own magnifying lenses. And this is what he made. And he was able to reach a magnification of 250 times.
By looking at everything from water to the plaque on his teeth, he found the world teeming with all kinds of strange microscopic creatures.
That made him the first scientist, so to speak, to discover the invisible world of microbes.
But in fact, these creatures have been with us all along. Single-cell bacteria evolved 3.5 billion years ago. They are the oldest life forms on Earth. En masse, these microbes exhaled oxygen, which eventually formed our modern-day atmosphere and created an ecosystem that changed the face of the entire planet. Scientists believe our oxygenated ecosystem led to the evolution of multicellular life forms at least 600 million years ago. And this, in turn, led to the evolution of even more complex creatures, including us humans. In this light, microbes are the most fundamental part of being human.
They digest your food, they produce all kinds of different vitamins and hormones. So microbes are essential to our way of life.
Scientists call this vast collection of microbes living in us and on us the human microbiome.
In essence, you're a walking ecosystem.
That's honestly mind-blowing.
Each body is a unique, walking ecosystem. But how exactly do these trillions of microbes contribute to a person's well-being? And how do we get our individual microbiome in the first place? To find out, I've come to Rutgers University to meet biologist Dr. Maria Gloria Dominguez-Bello. She's researching each person's dynamic relationship with their own individual microbiome.
Microbes are part of us. If we didn't have them, we wouldn't be healthy. We are now understanding that we didn't evolve alone. Every animal and plant on Earth evolved with bacteria in particular.
Like a coral reef or a rainforest, the microbiome is an ecosystem unto itself.
When you have an ecosystem that is perturbed, the first question an ecologist asks is, can you restore the ecosystem?
Gloria's understanding of the microbiome started in, of all places, the Amazon jungle, where she saw firsthand how human microbial ecosystems can quickly change.
I've been working in the Amazon for the last 30 years, since I was a student. Amerindians have been living there, pretty isolated, for the last 20,000 years. And I was very interested in understanding the microbiome of traditional peoples.
Through skin, mouth, and fecal samples, she measured the impact that external environments in which people lived had on their internal ecosystems. Gloria found that those living in the Amazonian jungle have a significantly higher diversity in their microbes as city dwellers living in industrialized countries. But when an individual from the remote Amazon moved to the city, they quickly lost their microbial diversity. This leads to a startling conclusion.
So that work has shown us that urbanization depletes and destroys the diversity of the microbiome. And in the gut, diversity is good. We know that because diseases decrease diversity, and when you decrease diversity, you cause disease. There is a strong association between high diversity in the gut microbiome and health.
Knowing how vital microbiome diversity is in fighting disease, Gloria is investigating how humans acquire microbes in the first place.
Here we go.
And how do babies originally acquire their microbes?
Inside the uterus, the baby is not being exposed to microbes, but once mom breaks water, the baby comes in contact with the birth canal, which is loaded with massive amount of bacteria.
It turns out the acquisition of microbes starts when a child is born.
By the time the baby is out, the baby is heavily colonized. So it's a microbial baptism. Then there's a skin-to-skin contact, that's the secondary exposure. Then the mouth of the mother kissing is another exposure. The environment of that baby is heavily maternal, and mom is a main source of bacteria. That first set of bacteria start the process of immune education. The immune system will recognize the good bacteria, don't attack.
But modern medicine is changing the immunity education that comes from this microbial baptism. The rate of cesarean births is increasing. Since 1990, C-sections have more than tripled, going from around 6% to 21% of all births globally.
C-sections successfully take the baby out, but without passing through the birth canal. This means that C-section babies are born from a sterile uterus into the air of an operating room.
And Gloria has discovered that this may increase the risk of many diseases.
C-section has been associated in humans with increased risk of the modern diseases. For example, an increased risk of asthma, type 1 diabetes, allergies, and obesity.
Starting at birth, the first 3 years of life are critical in establishing a healthy diversity of microbes.
I think it's just fascinating that many new parents are probably quite unaware that the first few years of life are so important for the baby's development of their microbiome.
Not only that, Gloria's research is revealing that the overuse of antibiotics to eradicate harmful microbes early in life is leading to a bigger problem than we ever realized.
We have impacted every step of development. The average baby receives 2.7 doses of antibiotics in the first year of life. We have been so successful controlling infectious diseases, but what we didn't know was the collateral damage that was caused to our microbiome. We have increased the risk of our kids to live lives with chronic diseases. We evolved with this biology. We cannot ignore it, because if we do, we are screwing the health of our future generations.
While helpful in many ways, sterilization of modern-day practices like C-sections and antibiotics could actually be harming our microbiomes, making us more susceptible to disease. But we can't just get rid of modern medicine altogether. Antibiotics and C-sections still save millions of lives. So what's the right approach? Gloria has invited me to her home to meet her husband, Dr. Martin Blazer.
Hi, Julia, lovely to meet you.
Martin is a microbiologist who also researches the microbiome. When it comes to using antibiotics, both Gloria and Martin believe we need a better balance.
By and large, we have overestimated the value of antibiotics. We're giving antibiotics like water. The big dogma is it might not help you, but it won't hurt. But what if it does hurt? There's more and more evidence we're losing microbial diversity. It's just going down.
Martin and Gloria want to prevent the further loss of diversity in our microbiomes.
We've overdone it. Now we have to find a more moderate approach. And ultimately, if we find a more modern approach, then maybe we can stop the decline in diversity. But how do we get it back? That's going to require restoration.
One intriguing candidate for microbial restoration is the H. pylori bacteria, the same one that Barry Marshall infected himself with.
Most doctors in the world are trying to get rid of Helicobacter on the idea that it's a bad guy. And it is, but since then we've been finding all kinds of good things that the bacteria does.
It turns out that some microbes are double agents and can be both bad and good for the body.
What are the good things you found out about H. pylori?
Well, we found that people who don't have Helicobacter have more disease of their esophagus. And we also found that children who don't have Helicobacter have more asthma. And that's really big, because asthma is going up, Helicobacter is going down. We think that they're linked.
Though it's been with humanity for millennia, today only 5% of children in the US have the H. pylori bacteria. So if H. pylori can cause stomach cancer, but eliminating it increases rates of asthma, what should we choose? It turns out we may not have to.
I predict that we'll be giving Helicobacter pylori back to children so that we can protect them against things like asthma. But we might want to eradicate it when they're 40 years old so that they won't get stomach cancer.
We have to treat these bugs differently in childhood and once you're an adult.
This revelation shows how we could begin to get the balance right. By treating the microbiome differently at different stages in a person's life, Gloria and Martin's dynamic approach could be the key to eliminating modern diseases.
In the future, nearly every baby is born naturally at home. When C-sections are needed, babies are bathed and infected with microbes taken from the mother's birth canal. From childhood, everyone receives personalized doses of healthy microbes as regularly as vaccines. Only prescribed in severe cases, the overuse of antibiotics has plummeted.
If the key to a disease-free future lies in managing the balance of good and bad microbes, then what we put into our bodies will have a huge impact on the microbiome. To better understand how the body's microbes work as a whole, I've come to San Diego to meet Dr. Rob Knight. He's looking for ways to create a better balance in individuals' microbiomes by sequencing their DNA. Based on numbers alone, this is a very daunting task.
You have about 20,000 or so unique genes in your human genome, but you have millions of genes in your microbiome. And all of those microbial genes, we're just finding out about how they make us who we are.
That is incredible that we call ourselves human, but maybe we're not so human after all.
Rob's quest is an ambitious undertaking. Through the American Gut Project he co-founded, he's crowdsourcing and analysing stool samples from across the planet. And because it's an open source project, he'll ultimately share the conclusions of this big data with everyone. For now, by sequencing microbial DNA from a wide array of people, Rob's pioneering work is diving deeper into the human microbiome than ever before, especially in how our microbes respond to food. In tandem with this, Rob's team is also sequencing the DNA of the microbes that colonize the foods we eat to analyze and compare its impact on microbes in the human body.
So what did you collect from the garden today?
So we got another set of fruit and vegetable samples.
So rosemary, tomato, eggplant we got today.
Great.
By understanding the microbial big picture, Rob has discovered something surprising.
One of the most fascinating and most unexpected things was the particular ways that diet impacts the microbiome. Categories that people think are going to make a huge difference, like are you an omnivore, are you a vegan, are you on the paleo diet, that kind of thing. It has almost no bearing on your microbiome results.
This research is contradicting prevailing wisdom. It turns out, what does affect the health of our gut microbiome is much more basic and even achievable for most of us.
The things that do matter turn out to be things like how many different species of plants you ate in the last couple of weeks, things like do you eat a lot of salty snacks or sugary snacks.
Wow, that is really interesting work.
Rob's research is showing that eating at least 30 different types of plants per week leads to a more diverse gut microbiome. And this matters, because this helps create a better balance of both the beneficial and harmful microbes that are in everyone. This microbial diversity dramatically increases the body's well-being. So, eat your veggies. But everyone's microbiome is not alike. Like a fingerprint, your gut microbiome is unique and responds differently than others. It even plays a role in how individuals respond to prescription drugs.
One of the major things that we and others are trying to find out at the moment is how do you know what medications are going to work? It turns out that the microbiome explains a lot of that individual variability.
That's because gut microbes play a role in how medications are metabolized in the body. An individual's microbiome can impact the effectiveness of drugs for Parkinson's, high cholesterol, and many other conditions. A better understanding of this complex relationship could lead to major breakthroughs in healthcare.
This is already being exploited right now for cancer drugs, and so that's a very exciting frontier.
I want to see if there are measures I can take to achieve a better microbial balance today. So I'm conducting a little experiment of my own with a sample kit from the American Gut Project,
which contains tubes and swabs and some gloves. So I think we can all imagine exactly what this is for taking samples of.
I'm eating junk food for 3 days, and then a wide range of vegetables for 3 days.
And I'll be taking 2 samples after the healthy food and after the unhealthy food and seeing if my microbiome has been altered.
Oh, I'm gonna be sick. That is horrible.
I'm bringing these samples to Dr. Jack Gilbert, the other co-founder of the American Gut Project. His team is using this research to tease out the body's specific relationship between our microbiome and the development of disease.
What have you brought us?
Well, this is a little bit mortifying. I have brought you some samples from a small experiment that I decided to conduct on myself.
Yeah.
I want to see if the health of my microbiome improves in the short term. Do you think that change could be seen in 3 days?
It's a little short.
Limitation
Yeah, exactly.
of time.
Precisely.
A bit short, yeah.
But it's enough to see some changes starting to occur.
While the samples are processed, Jack walks me through the complex relationship between our microbes, food, and disease.
What we found was if you had a stable microbiome that was, say, promoting obesity, i.e. a microbiome that made you fat by producing chemicals which changed your relationship to food, it would take almost a year on a new diet to eradicate those microbes and change it to one that doesn't promote weight gain. That's the problem with diets. Nobody stays on them for an entire year.
Also contributing to the chronic disease of obesity, a modern-day diet of highly processed foods can cause the microbiome to become imbalanced.
Too much sugar, too much saturated fat is changing the types of bacteria which live inside us.
To test the relationship between the microbiome and weight, researchers took fecal samples from obese mice and transferred these samples into the guts of lean, germ-free mice. Incredibly, this transfer changed the microbiome of the lean mice. After the microbial transplant, the lean mice gained weight and became obese. It turns out that gut bacteria play a big role in regulating the body's overall metabolism. Jack believes microbiomes adjusted for poor diets have a similar negative effect on humans, leading to any number of debilitating diseases.
And we think that is having an impact upon things like diabetes and obesity, maybe even depression and anxiety.
Similar microbiome transplant studies with mice suggest there is also a connection between the microbes in our guts and Alzheimer's.
I am really interested in the link between the gut microbiome and Alzheimer's disease.
You have a family history of Alzheimer's?
I do, yes. That's my motivation for doing a PhD in the first place.
So I have the genetic precursors as well. It's
Yes.
one of the wonderful gifts my mother gave me.
Yes, probably mine too.
Exactly. There's a number of different ways the microbes in your gut can affect what goes on in your brain.
One pathway is the vagus nerve. This long nerve connects the intestines with the brain, creating a two-way channel of communication. Research suggests that stress signals from the brain may cause gastrointestinal distress, while signals from the gut may alter mood. The brain and gut are also connected by the body's immune system.
And this is very relevant for Alzheimer's and Parkinson's, is the microbes in your gut change how your immune system works. They can cause inflammation that spreads throughout the body and then can change how the brain is receiving information and how the brain is receiving chemicals.
Jack's research suggests that by eliminating inflammation-causing microbes in the intestines through medication or dietary changes, we might prevent Alzheimer's disease.
And that is a phenomenal change in understanding.
This gives me hope that no one else in my family will have to suffer from this crippling disease in the future.
With these neurodegenerative late-life diseases, patients often have changes in their brain years before you see any symptoms. Do you think we could see an almost microbiome signature of these changes and then jump in with some early preventative measures?
I think that is absolutely possible, right? In combination with looking in your blood and seeing if there are biomarkers of the disease, we could also look in your stool and look at the types of microbes which would cause the disease to start progressing. So we may be able to transform our ability to predict it early in the future.
Jack is developing a new technology that will allow people to track biomarkers in their gut microbiomes at home.
This is a mock-up that we're using.
Very nice.
But we've developed a toilet seat, literally just this part of the toilet, that allows for the collection in an automated way of stool.
Yeah.
And then provide you with updated, regular information about the microbes and their functions that are present there. Or we might be able to provide you with an update on what kind of foods you should eat. Then we may be able to prevent disease from developing in the first place by changing what microbes are present in your gut. That would be a phenomenal improvement in our understanding of human health.
As for my short experiment, the fried and fatty junk food had a negative impact on the balance of my microbiome. Jack recommends sticking with healthier eating and consuming more fibre. By analysing, optimising and managing our own microbiomes, we could create a future where diseases are kept at bay.
In the future, many people perform health checks by profiling their microbiomes at home. In real time, toothbrushes sequence the DNA of billions of microbes in the digestive tract. The data is networked with appliances, allowing individuals to receive automatic daily food deliveries that are personalized for optimal health. This data also syncs with medication dispensers, which fine-tune prescriptions to diversify the microbiome and boost the immune system.
Since studies have shown that microbiome transplants can be used to transfer diseases from one animal to another, I wonder if this same technique could be used to cure disease as well. I'm outside Boston to meet Carolyn Edelston. Her Open Biome organisation is combating a notorious bacteria, C. difficile, or C. diff. Open Biome is helping fight this life-threatening gut infection with a radical treatment: human fecal transplants.
C. diff, or C. difficile, is the most common hospital-acquired infection in the US, actually.
Who is at risk of contracting it?
Oftentimes what happens is someone will go into a hospital or a long-term care facility, they'll go on antibiotics, and they'll acquire a C. diff infection. What happens when you go on antibiotics is a lot of the microbes that are normally present in your gut get wiped out. And without that competition, C. diff is able to spread and to start producing the toxin that makes you sick. C. diff is really difficult to kill and to get rid of because it makes little spores.
These toxic spores are C. diff's most ruthless weapon against the body.
Because of this, it's pretty easy for patients to be colonized by C. diff.
C. diff infects 500,000 Americans every year, with a staggering mortality rate as high as 30%. But a novel solution has been developed to change the gut's ecosystem and restore and rebalance the gut microbiome of those infected.
Most of the time, C. diff can be treated with a fecal transplant. So you take a sample of stool from a healthy person, and in that stool is trillions of bacteria that live inside our guts. And what we're doing is transferring that community of bacteria into the colon of a patient to outcompete the pathogen.
Similar approaches were pioneered by the Chinese in the 4th century when they prescribed yellow soup made with fecal matter to treat colon diseases. By rebalancing and rediversifying the gut microbiome, the return of beneficial bacteria should keep the C. diff infection in check. Associate Director of Biomanufacturing, Delassi Delasesci, is going to show me how they make this cutting-edge science a reality.
Hairnet first, face mask, a couple pairs of gloves, lab coat, and shoe covers.
And why do we have to wear all of this gear?
To make sure that as humans, we're not contaminating the product that's going into an already compromised patient.
I mean, I'm looking fantastic, so
Great.
feeling great, looking great, ready to go.
Perfect. Awesome. This is essentially the first step.
Yeah.
This is where they'll do a visual assessment of the sample.
And what are the assessment criteria for a piece of poo? Like, what is a good piece?
So there's a visual assessment for color. It's also assessed for size. There's also a scale that we grade the stool on. It's going to give you viscosity, texture, hardness.
I never thought I'd say I'm looking forward to seeing a piece of poo.
Yeah.
But here we go. I'm excited.
So this is the actual stool that's going to be processed. What would you say this one is?
We determined that it would be a 4.
A Bristol 4, essentially, that's kind of known as like the perfect texture for a stool sample to come in, and then she'll continue processing.
I feel like it's really interesting though, like you guys are obviously quite immune to it maybe because you work with this every day. For me, that was like, whoa.
Once the microbial diversity of the stool samples are determined to be sufficient, they are stored in giant freezers.
Oh wow, there are a lot of freezers.
Welcome to the freezer farm.
It's amazing.
These remedies are stored at -80 Celsius to keep the healthy bacteria viable before shipping to hospitals and clinics.
So they're mixed with a saline and glycerol solution. This is a fecal microbiota preparation that'll be delivered by colonoscopy. So this is the most common treatment format that we make. And this is what it looks like.
To date, OpenBiome has shipped over 50,000 fecal transplant treatments around the world. Though not fully approved by the FDA yet, the treatment looks promising.
About 85–90% of the time, you deliver a single infusion of stool into a patient's colon, and they'll beat the C. diff infection.
That's really amazing.
For one lucky survivor of C. diff, Jen Cooper, this fecal transplant procedure was her only hope.
Hi! Can you tell me when you first got sick? I first got sick a few years back when I'd been hospitalised with gallbladder infection, which turned into a blood infection. So they put me on extremely strong antibiotics. All the antibiotics I had just killed all that good bacteria in my tummy and finally got diagnosed with C. diff. What were your symptoms of the C. diff? I'd go to the toilet 15 times a day. The exhaustion was just crippling. So much fatigue. I would spend days in bed. It messed with your head, it messed with your body. It was a nightmare.
So it really did like flip your life upside down having this condition.
Oh, absolutely. You just get to a point where you're so over it. You just want help.
But the fecal transplant had a tremendous impact as beneficial bacteria kept the C. diff infection in check.
I feel like a different person. I feel years younger. I have energy. It's above and beyond what I thought it would do.
Oh, well, I'm wishing you all the luck.
Scientists are now investigating whether this treatment might work for other conditions like obesity and autoimmune disorders as well. Novel medical approaches like this that harness the power of a balanced microbiome are forging the future to a disease-free world.
In the future, Full microbiome replacements are mainstream procedures to fight modern diseases. Recipients first select from a large catalog of ultra-healthy donors. In the clinic, patients' microbiomes are completely replaced with entirely new microbial ecosystems. Once the recalibrated microbiome takes hold, it re-engineers the body itself, prompting healthier eating habits, more desire for physical activity, and a heightened mental state.
If there's one thing I've come to realise, it's that microbes can be as much a source of good as they can be for harm. But to find our way to a disease-free future, the trick is getting the balance and diversity just right. And it's not a straightforward path at all. No one knows this better than Dr. Jack Gilbert, whose own path of restoring the healing power of microbial diversity has been full of twists and turns. One very important reason Jack is motivated to pursue this research is his own son.
I have a child with autism. As soon as I found out that my son might be slightly different to other people, I always wanted to figure out a way that I could help him. I don't think autism is a disease that we need to fix, but I did want to be able to help him to realise his full potential, as any parent would.
About 2% of children in the US are diagnosed with autism. Recent studies show that individuals with autism have abnormal gut microbes. So Jack has been working on rebalancing the microbial diversity of those with autism, including his son.
We actually developed a dietary supplement to improve his health. So he eats a lot of fibre now, and he takes butyrate supplements and omega-3 supplements that help him to regulate his behaviour and his health.
But Jack has found that the most effective way to boost microbial diversity is to boost humanity's interaction with non-sterile natural environments.
Kids need physical interaction with the environment. Physically interacting with the world around them shapes how their immune system works, which can protect them from allergic disease, asthma, maybe even obesity and neurological diseases like depression and anxiety. We think this might be fundamental to the process by which a human body develops. I think that's the best recipe, is let kids play in the dirt.
And it's not just natural environments that give this kind of boost in the fight against modern diseases. Exposure to animals can also play an important role.
We published some research which suggested that when you had dogs interacting with your family, it actually increased the amount of microbial exposure children got, and it increased the degree of microbial sharing between people. We know that children that grow up with physically interacting with a dog under the age of 1 year old, when they're very young, have a 13% reduction in the likelihood of developing asthma. It's huge, right? If they grow interacting in a farm environment, there's almost a 50% reduction in likelihood of developing asthma.
To investigate this relationship between microbial diversity and the natural environment, Jack spent time studying 2 different communities that live on farms, both of which practice 19th century agricultural ways of life.
We started exploring 2 groups of people in the United States called the Amish and the Hutterites. They both live a very rural existence where they don't really like technology, no cameras, no televisions, etc. But they have one very specific difference.
While both communities lead a rural lifestyle, Hutterite children don't interact with farm animals or crops, but the Amish children do.
The Amish, kids grow up milking cows and working with the animals, and we think that the exposure they get to that farming environment, to the microbes in the cows and in the sheep and in the horses, actually trains their immune system. The Hutterite kids are severed from their interaction with the farm, and we see this reflected in their health.
As a result, Hutterite kids don't acquire the subsequent immunity training from this exposure.
The Amish only have about 4% asthma in their population. That's half the US average, whereas the Hutterites have a significant elevation in the disease rate.
With these dramatic findings, Jack's lab has been looking at ways that those of us who live in more sterile urban environments can bring the microbial diversity of the farm back to our bodies and our microbiomes.
We've got one strategy that we've been developing. We have living surface materials with bacteria that we could place in a home or a hospital even, and enable that home or hospital wall to have the beneficial properties of, say, a farm. Sounds a little bit science fiction-y, but in the future, we may be able to build entire cities out of biologically alive materials, and maybe even spaceships. We work with NASA on trying to see if these materials could be beneficial for long-term spacecraft missions to Mars, for example.
Oh, amazing. That is really interesting.
On my journey towards a disease-free future, it's become clear that humanity's relationship with our microbes is complicated.
I didn't realise the importance of the human microbiome and how important it is for our individual health.
We need to balance the bad with the good, but we're running out of time. In an era of deforestation and urbanisation all over the globe, the struggle today is to preserve the diversity of microbes that make up the human microbiome before it's too late. But as a scientist, I know to never underestimate human creativity and innovation for solutions.
In the future, what we want is really to understand which are the microbes that are essential, what is their function, and then be able to use them as probiotics. So we are part of an initiative called the Microbiota Vault.
A joint project of Gloria, Rob, Jack, Martin, and many others. The Microbiota Vault will be like a Noah's Ark for microbes.
Microbiota Vault, it's a project that has long-term storage in a very isolated place to collect microbial diversity from traditional peoples and then be able in the future to use them to restore our microbiome because we know it's going to disappear.
I believe a vault like this may provide one important key to the disease-free world of the future. And armed by this arsenal of microbes we evolved with, scientists will open up a trove of new methods to fine-tune our microbiome and improve the health of everyone.
In the future, I think microbiome research is going to lead to the possibility of having customized microbiome therapy, what we call personalized medicine.
By bio-augmenting our bodies with new microbes, we can train our immune system to attack cancer. We can alter the types of bacteria living inside us to treat depression and treat things like obesity and diabetes. That will have a fundamental impact on how we deal with our modern-day plagues. Microbiome is going to revolutionize medicine.
As for me, my hopes for medicinal applications hit a little closer to home, and it's inspired my research in neuroscience. With any luck, microbiome therapy may one day provide a remedy for Alzheimer's and other diseases. But for the world as a whole, my hope is that the restoration of the microbiome will not only boost the health of everyone, but lead people to happier and more fulfilling lives.
This is what the future of genetic engineering looks like. With advanced DNA editing techniques, vaccines for deadly infectious diseases with no side effects are developed in a matter of weeks. Genes from any plant or animal can be combined to create new hybrid organisms resilient to climate change. This technique can even restore extinct species. Doctors can detect every known genetic disorder early on and repair mutations quickly, giving children happy and healthy lives.
Our environmental clock is ticking.
Today, scientists are blazing a trail to this very future.
Tinkering with genes is actually an ethical thing to do.
I want to know, what breakthroughs are being made?
Technologies like CRISPR are incredibly powerful.
What we're doing here is really the beginning of a true revolution.
That will forge the future too.
That is incredible.
The rise of genetic engineering. My name is Kandwani Piri. I'm a genetic researcher. You could say it's in my blood.
From an early age of about 8 or 9 or so, I had just a natural curiosity for the natural world.
Cancer runs in my family. In fact, I lost my aunt to breast cancer.
And that piqued my interest in genetics.
I'm fascinated by how the genes we inherit shape our biological destiny, including our health. I believe the key to treatments and cures for diseases like these lies in explicit efforts to engineer human genes. But can we fix not only what's broken, but also enhance our genetic codes and improve on Mother Nature? Someday, will humans direct their own evolution? And should we? I'm starting my journey in Washington, D.C. to visit a family who's grappling with the difficulties caused by genetic disease.
Hello. Hi, Annabelle.
Can you shake hands, Annabelle?
Hi. Oh my gosh. How are you? Oh, I think she's shy.
4-year-old Annabelle Frost has a heart-wrenching genetic disorder.
Could you tell me a little bit about Annabelle?
When Annabelle was born, it was such a wonderful moment. But we were in this happy fog and didn't notice the nystagmus, the eye movements. We didn't notice the jerky muscle movements. We didn't notice any of that. But the doctors realized that something was wrong.
They diagnosed Annabelle with alternating hemiplegia of childhood, or AHC. This extremely rare disorder causes debilitating spells of paralysis, delayed development, and life-threatening seizures.
She'd have days of paralysis where her whole one side of her body, she'd drag it along behind her as she crawled.
Once a day, she will have these choking episodes where I need to pick her up and hit her on the back to make sure that she could breathe.
Annabelle's condition is a result of a problem in her DNA. The twisting double helix of DNA is made up of 4 different base pairs, or nucleotides. The unique sequence of these base pairs are instructions for the body to make proteins. The base pairs are like musical notes in a score that tell a musician how to play a song. When all the different sections of the DNA are played, the result is a biological symphony. But like a musical note played out of key that compromises the entire performance, there is an error in one of Annabelle's genes. The mutation in the ATP1A3 gene is disrupting her nerve cells, leading to her severe condition. AHC is fundamentally intertwined in her genetic code. There is no restorative treatment or cure.
The medicines that they have are kind of more about masking symptoms in a very unspecific, untargeted way.
And we wanted to try to figure out if there was a way to address the cause and not the symptoms.
Without targeted treatment, Annabelle could die any day.
There's a timeline on this for us. We've got a ticking clock in the back of our minds all the time.
The Frosts are desperate for any kind of help. From sickle cell anemia to Huntington's disease, millions of people suffer from thousands of genetic disorders, much like Annabelle's. Unless scientists can address these genetic errors, children like Annabelle will suffer agonizing pain, and some will die young. I want to know, can genetic engineering help families like this in the future?
Oh, that's so nice.
The double helix structure of DNA was first revealed in 1953 by Rosalind Franklin, Francis Crick, and James Watson. And within a few decades, scientists discovered how to alter the DNA of living organisms. But gene editing really took off around 2013 when scientists harnessed a molecular mechanism found in certain bacteria. This remarkable mechanism is called CRISPR-Cas9, or CRISPR for short. CRISPR-Cas9 contains an enzyme that serves as the bacteria's defense mechanism against viruses. When viruses infect the bacteria, the CRISPR machinery targets a specific section of DNA. Then, the enzyme responds like a pair of scissors and literally cuts the virus's genetic code apart. Scientists are now harnessing this natural mechanism to target and precisely edit the DNA of numerous organisms. To find out how, I'm heading to a biotech lab in Brooklyn, New York.
I'm on my way to Gen Space, which is the world's first community biology lab.
Beth Tuck is the Director of Science Education at Gen Space.
We are an open access science lab. We're a community biology lab.
So you're telling me if I'm a computer programmer and I want to learn more about biology, I could essentially come down here and take a class and use your facility?
That's it.
Beth is going to show me how to use CRISPR in the lab to edit a bacteria's genes in new and novel ways.
I brought this kit. Could you explain a little bit how this kit works?
Yeah, sure. Got a pipette. This is our measuring device. Got a rack where we'll put some of our plastic tubes, some plates, petri dishes, and then our E. coli.
E. coli is a type of bacteria that lives in the intestines of humans and animals. Though some strains can be deadly, most are harmless.
Gloved up, let's do this.
All right, so we've got our E. coli here. These are called DH5 alpha, which is a type of species that isn't harmful to people with normal immune systems.
That's good to know.
So our first thing that we need to do is actually get these bacteria out of this jar. And so you just kind of scoop it in there. Yep, swirl it around, bring a little bit up. The way that this experiment works is we're gonna spend a day to prepare the bacteria.
Next, we insert a CRISPR construct that will alter their DNA.
So we're gonna add in the CRISPR machinery and then change the cells.
The CRISPR machinery targets and edits a specific gene in the E. coli so that it can adapt to a lethal dose of antibiotics. Normally, bacteria can't grow in the presence of this antibiotic. The drug kills the bacteria.
We need to get these bacteria onto this plate so they can grow. You're just gonna gently drag it across the surface of the plate.
That's it?
Yeah, that's it.
Over the course of several days, Beth grows the gene-edited bacteria in a petri dish laced with the E. coli killing antibiotic. But despite this toxic onslaught, the genetically altered E. coli continue to grow.
I see plenty of growth.
The whole point of this is to show that changing an organism's DNA can change its features, and that you can do it with CRISPR in a really precise way, in a way that wasn't feasible before.
What kind of positive outcomes can we expect from using CRISPR?
You can use it to design new on-the-spot testing for infectious diseases. You can use it to cut out HIV from human cells. There's so many more uses that we haven't even imagined yet. That, to me, is why this stuff is so exciting.
Harnessing the natural ability of CRISPR and transforming it into a technological tool has the potential to address all sorts of problems.
In the future, advanced gene editing techniques are reworking microbes to create healthier lives. Bacteria are engineered into mini pharmaceutical factories. These microorganisms generate an inexpensive, abundant supply of medicines for diseases like malaria, rabies, and coronavirus. And specially modified yeast converts organic waste into green biofuels. This innovative energy source is not only renewable, but it also packs more of a punch than regular fossil fuels.
Formulated by Charles Darwin, natural selection is the driving force of evolution. While many individuals perish, the species best adapted to their environment survive and reproduce, passing along their advantageous genetic traits to their offspring. These traits, like height, eye color, strength, and even personality, are contained in genes. Over generations, the process of natural selection perpetually fine-tunes the species at the genetic level, helping individuals to continually adapt to changes in their environment. humans learned to direct this evolutionary process through artificial selection. Through the intentional selection of mates, humans facilitated the breeding of animal offspring with desired characteristics. Arguably, the first known example of artificial selection happened more than 15,000 years ago when humans domesticated the wolf, breeding what we now know today as the dog. In agriculture, artificial selection has improved and even created new fruits and vegetables. Through selective breeding for certain traits, the simple wild mustard plant was transformed into cauliflower, cabbage, and even broccoli. But even artificial selection takes at least a few generations to work. Capitalizing on the natural CRISPR process, gene editing in the lab can compress evolution down to a matter of months. Using CRISPR to manually engineer DNA is the next step in accelerated evolution. And with this remarkable tool, scientists can even improve our food supply. This matters because over 10% of the world suffers from hunger and malnourishment. I'm in Raleigh, North Carolina, where pioneering food scientist Dr. Rodolphe Barangu is using gene editing to boost food production and feed the planet.
We're going to be able to breed crops that are more efficient, that are more resistant to disease. The biggest impact CRISPR may have short term, maybe the next decade or so, will be to revolutionize a food supply chain.
In fact, Rodolphe had a hand in the discovery of the natural CRISPR mechanism in bacteria, and his use of CRISPR as a technology in milk is leading to remarkable innovations in dairy products.
So what we're looking at here is milk that is the process of fermenting.
Okay, so this is in the earlier stage of things.
Very early stage. So we add the bacteria to start the fermentation process, and then use the lactose to solidify milk into cheese and yogurt.
In most dairy facilities, regular bacteria and yeast kickstart the fermentation process. But before starting, Rodolphe added a twist. He used CRISPR technology to enhance the bacteria used in the fermentation of milk.
We used it to build resistance in bacteria that make cheese and yogurt, to have better fermentations and better manufacturing of dairy products.
By vaccinating the bacteria, his dairy cultures almost always succeed, which improves the process of making yogurt and cheese. Processes like these also make them healthier.
CRISPR has been a life changer, and then also has opened tremendous avenues to provide a healthier and more sustainable food supply for humanity.
But the true revolutionary potential of CRISPR technology is just now starting to be realized.
Other people caught on to using these molecular machines to actually cut DNA to do genome editing, not just in bacteria, but in other organisms. By understanding what CRISPR is and how it works, scientists were able to develop technologies that enable us to now change the world.
By 2050, the world population is expected to soar to 10 billion people. Food production will need to increase 70% to catch up. To feed our growing population with the same amount of farmland, the mass production of food must be hyper-efficient. At NC State's Plant and Microbial Biology Lab, Rodolphe's colleague, Mary Beth Dallas, is facing this daunting prospect.
I manage this lab, and I also do research on cassava.
Also known as the yucca plant, cassava is the primary food staple of nearly 1 billion people.
Cassava plant is very close to my heart.
This root vegetable is kind of like a potato and is widely grown across Africa and the Americas.
They can actually harvest the tubers and make flour, and they can make breads out of that. They can also eat the greens. It's really a nice plant.
Yeah, and me being a native Zambian, that's where I was born, I grew up eating cassava as well as cassava leaf, so it has a special, I know all about it, so it has a special place in my heart as well too.
But there's a problem. A malady called cassava mosaic disease is ravaging this critical food source. In Africa alone, it's destroyed cassava crops, leading to numerous famines.
You can see here the devastation of the plants. It gets really thin leaves, and a mosaic pattern occurs. When the leaves get destroyed like this, they cannot photosynthesize properly, and the tubers that are under the ground cannot get the right nutrients, and they get all shriveled, and then you can't use the tubers for the food. We want to combat and try to find a way to stop the devastation of these crops.
To wage this war, Mary's lab must take an experimental approach. Using what's called a gene gun, CRISPR-altered DNA is injected into the cassava plant.
We bombard the stems with the CRISPR construct, and what happens is the leaves grow up.
In principle, as the leaves and tubers grow from the stem, the plants will become more resistant to the crippling mosaic disease.
When could we see a possible usage in African countries that are afflicted?
We're still trying to hone in that technique. So hopefully we'll get it soon.
Imagine, gene editing could help end world hunger.
This is also applicable beyond crops to things like trees. Forests may be the biggest farms that we have.
But as the human population grows, so do our agricultural needs. This leads to deforestation, which is one of the primary causes of climate change, contributing to the record high temperatures we see today. To reverse this scary trend, one solution is to plant more trees to absorb greenhouse gases like carbon dioxide. Rudolph is collaborating with tree biologist Dr. Jack Wang to grow more trees, and fast.
What do we have here?
So these are transgenic trees.
Jack's lab has created over 10,000 types of genetically modified trees. The goal is to optimize traits for different industries, like timber or paper, to reduce their environmental footprint.
We deliver CRISPR into these cells.
Once CRISPR has altered the tree DNA, the embryos then grow enhanced roots and shoots.
So this has been engineered precisely for a specific genetic change using CRISPR.
This helps Jack to select for specific traits more quickly and efficiently than traditional plant breeding.
So this little bit of seedling is now a tiny little CRISPR-edited forest tree species.
This is at this stage just before it goes into the greenhouse.
That's right, so it's now ready to be grown for 5 to 6 months.
Fantastic, so cool.
Jack's next step is taking these seedlings over to the greenhouse where they'll be fully grown and studied.
Compared to 15, 20 years it takes to breed a tree in a natural population. In the greenhouse setting, we can analyze and produce new genetically improved trees in as little as 5 to 6 months.
That is incredible, 6 months.
Here they're quickly growing poplar trees, which is the most effective species at absorbing carbon dioxide from the air.
They can capture a very large amount of carbon from the atmosphere, and we have to start solving the problem right here, right now. We can not afford to wait for another 20 or 30 years.
This technique for breeding trees is giving reforestation efforts a major jumpstart.
Our environmental clock is ticking, and we want to create a better, healthier environment for future generations. It's something that has to be done now.
What we're doing here is really the beginning of a true revolution, the next green revolution, coming to a forest near you.
Yes.
I think it's going to revolutionize our world and solve the grand challenges that we have on the planet.
A new CRISPR-fueled green revolution will forge a path to a more bountiful world.
In the future, gene-edited plants are addressing world hunger and climate change. Enhanced food crops grow in harsh conditions, even in water-parched deserts. Thanks to these disease-resistant plants, famines across the world are a thing of the past. New fast-growing forests collectively take in the excess carbon dioxide from the atmosphere, cooling the climate and restoring balance to the world's ecosystem.
As I see it, gene editing is both a faster and more precise method for artificial selection. While it works in microbes and plants, how feasible is gene editing in more biologically complex organisms, like animals? I'm in Davis, California, to meet geneticist Alison Van Eenenum. She's a pioneer in this field, and I'm getting acquainted with her work.
Oh no!
Scientists tend to be problem solvers and want to try and address problems using the best method they can. And my lab is trying to breed better cattle.
There are about 1 billion cattle on Earth. That's a lot of animals to manage. But Allison is making cattle farms safer by eliminating one particular trait.
I see some horns up here.
Okay.
Dairy cows have been bred to be very optimal for dairy production. And as it happens, dairy cows grow horns.
And these horns are a problem because they injure other cattle and ranchers.
You could imagine if this was a particularly aggressive bull that he could hurt his pen mates.
Instead of manually sawing off these horns, Allison is breeding a dairy cow that doesn't grow them in the first place. Working with a type of cattle that has no horns, she had their hornless gene inserted into horned dairy bull cells. These cells were cloned to make the hornless animal. These hornless cows are descendants of a gene-edited hornless bull.
These are proof of concept animals. They are kind of a prototype of how you could use genome editing.
This genetic technique produces offspring with a desired trait much more quickly than the decades of breeding normally required in traditional animal husbandry.
That's really what editing does for us, is it enables us to bring in one useful characteristic that we want, in this case, not growing horns, and not alter the rest of the genetics.
This technique shows that gene editing tools can be used to introduce desirable traits from one animal into another.
Outside of trying to remove the horns, are there any other expressions that we would want to get rid of or add?
So what else might we do? One of the targets that's a really obvious one for plant and animal breeders is disease resistance. And so globally, it's estimated we lose about 20% of all animal production to disease.
That's a large percent. That's hundreds of millions of cattle needlessly lost every year.
To me, genetics is the best approach to deal with disease, because if they don't get sick, they don't need to be treated with antibiotics, they're more productive, farmers happy, cattle are happy, consumers are happy. So it's kind of a triple win for sustainability.
But there's an even more fundamental trait that Allison is trying to select for.
In the beef cattle industry, we would actually prefer males.
That's because male beef cattle produce quantitatively more meat per pound of feed than females. So Allison is also using gene editing to breed cattle who only produce male offspring. To achieve this, she inserts a special gene into cow embryos in the lab. This makes selecting the male sex possible. This could save more animals from being slaughtered, and techniques like these could be used to insert disease resistance, potentially reducing the need for antibiotics. In fact, a gene-edited embryo was implanted into this cow just 3 months ago.
And there's Princess.
So in a few short moments, we're about to see an ultrasound of a cow here.
Veterinarian Brett McNabb is going to perform an ultrasound on Princess to see if the gene-edited embryo has taken hold.
We're just going to make sure that the pregnancy is still healthy and viable from what we can tell.
So an ultrasound on a cow is not quite the same as an ultrasound.
The principles are the same, but our approach is a little bit different.
Allison's checkup may depend on the whims of this mama cow to get the ultrasound scanner up her, well, you know.
You're doing that next time.
You know, I'm learning quite a bit just observing.
Oh, I see.
She's pregnant?
That's good news.
It appears the embryo implant has successfully taken hold.
So on ultrasound, we use sound waves, and so anything that's more dense is going to bounce the sound wave back to my probe. And then you can start to see floating around in there are those bright white structures. Those are all parts of the calf.
Oh, yeah, okay.
Based on certain structures, we can sex the calf, and it looked like a male.
For Allison's endeavor to breed male-only beef cattle, this is a significant milestone. While these techniques are still experimental and haven't yet been approved by the FDA, Allison believes that consuming products from gene-edited cattle poses no threat to human health. Artificially selecting for the male sex could make cattle production more humane and more efficient.
There are some pretty compelling benefits that outweigh the risks.
Seeing the genetic engineering of livestock up close and personal is absolutely mind-blowing.
In the future, engineering the genes of farm animals speeds up their evolution as useful domestic species. A new variety of cow, gene-edited to dramatically reduce the emission of the climate-damaging gas methane, is vastly reducing global warming. Organs from genetically modified pigs are safely implanted into humans without fear of rejection from the immune system. No one dies from a lack of an organ donor anymore.
Humans have selectively bred plants and animals, refining the traits for thousands of years. We've even created hybrids by mating creatures from two different species. For example, a donkey and a horse make a mule. But in the lab, mixing up genetics can result in anything and, well, everything. Jellyfish DNA spliced into a bunny results in a fluorescent bunny. When spider DNA is edited into goats, their milk can be spun into spider silk. Hybrids like these are often bioengineered for research purposes. But one scientist is using CRISPR's crossbreeding ability to do something truly ambitious. He's bringing back the genes of extinct species. I'm in Cambridge, Massachusetts to meet Dr. George Church, a legend in the field of genetics, one of the originators of gene engineering. He's been working in Russian Siberia to find the remains of woolly mammoths, with the aim of resurrecting their DNA to fight climate change.
There's unfortunately lots of melting ice in Siberia, and so there are millions of mammoths that are frozen that are becoming exposed. We had access to 6 really excellently frozen specimens that had never thawed in 40,000 years.
When you were grabbing the samples from the woolly mammoth, anatomically
we're dissecting big chunks of mammoth legs with a drill bit, and we're kind of suited up because there's meat flying all over the place.
Due to overhunting and environmental changes, woolly mammoths began going extinct around 10,000 years ago. But George is extracting their DNA from the cold, preserved remains in Siberia and mapping their genome.
So we read the genome into the computer, and then we write it into modern Asian elephant cells.
Modern Asian elephants and woolly mammoths share a common ancestor, but are 2 distinct species. George is using advanced CRISPR techniques to resurrect multiple cold-resistant genes from the woolly mammoth that grow extra hair and produce more fat. He then plans to integrate these genetic traits into the eggs of Asian elephants.
We can make dozens of edits to the genome and then clone them into baby elephants.
But why? It turns out cold-resistant elephants could also help mitigate global warming. In the frigid tundra of Siberia, grass is more effective at keeping the Arctic cold than the current forest environment, which retains heat.
Those billions of square kilometers are at risk of warming, and it's the only herbivore that can knock down the trees is the elephant. Oddly, the herbivores can change it back to grasslands, which is more photosynthetic.
And a sizable population of cold-resistant elephants would help maintain this region as grasslands through grazing. And a more photosynthetic Arctic would absorb more carbon dioxide.
So it's part of what will hopefully be a big international effort to convert the Arctic, at least partially back, to the form that was more conducive to fighting climate change.
Is it outside of the realm of possibility to, say, bring back an extinct creature like a woolly mammoth?
Once we get good at it, we may switch the cold-resistant elephants into fully genetically identical mammoths.
Who knew? Resurrecting woolly mammoth DNA could help restore icy conditions across the Arctic.
In the future, genes from most creatures can be safely inserted into other species to create revolutionary hybrids. Engineered jellyfish with genes from plastic-eating microbes now clean up the oceans by organically breaking down non-decomposing trash. Some scientists have even extracted DNA from dinosaur remains and are on the brink of resurrecting these extinct species. The hope is, by bringing a single dinosaur back to life, new technologies will be developed to help other species on the brink of extinction.
Speaking with George Church firsthand is both humbling and inspiring. As if resurrecting the DNA of the woolly mammoth wasn't enough, he also helped start the $3 billion Human Genome Project. This landmark study identified every base pair of DNA and mapped the entire human genome. Its primary purpose was to conquer disease. It was and remains a really big deal.
We are here to celebrate the completion of the first survey of the entire human genome.
This roadmap of the intricate genetic codes across the human body empowers doctors to better diagnose and treat disease.
We've worked really hard on bringing down the cost of reading genomes, which I think is the thing that most people could benefit from.
Thanks to advances in DNA sequencing technology, the cost of reading entire genomes has plummeted.
All it would take is a small tipping point event, shifted over so that everybody is using this. And in the case of genetics, that would be reading everybody's genome and giving them information that was actionable.
By actionable, he means letting individuals know what kinds of diseases they're genetically susceptible to. This empowers people to be proactive in avoiding or managing imminent diseases.
I think we're on a trajectory where everybody in the world are going to get sequenced within a few years.
The Human Genome Project continues to have a big impact in treating all kinds of human diseases. To find out how, I'm at the historic Cold Spring Harbor Laboratory in Long Island, New York, to meet with Dr. Bruce Stillman.
There's been a revolution coming from the Human Genome Project, and a lot of cancer research is linked to that. We now have a very deep understanding of that genetics, and what that can do is to link new therapeutics to individual patients' genetics.
I have an interest in oncology. I'd lost an aunt to breast cancer, and I think that took me down this journey towards finding a solution.
One of our scientists used a very interesting genetic technique of genetic selection, and now we're gearing up to use that information to improve cancer therapy.
Founded in 1890, this lab is home to 8 Nobel Prize winners.
So this was the first lab at Cold Spring Harbor, and it's still used. This is a cancer laboratory, so still used for cancer research.
Scientists here are using gene editing techniques, including CRISPR, to develop new ways to fight cancer. These advances are leading to treatments tailored to work with an individual's unique genetics.
So for instance, if you have a mutation in a particular gene that causes lung cancer, there is a therapeutic that is targeted to that lung cancer.
But in the shadow of its long history of using genetics to improve human life, Cold Spring Harbor Labs do have an unfortunate and dark past.
What happened in the 19-teens and the 1920s was that scientists began to believe that a lot of traits were inherited by individual genes when in fact they weren't.
This led to an era of what's called eugenics. That is, the selective breeding of humans. Cold Spring Harbor Labs even opened a eugenics records office to gather biological information on the American population. At the time, people with certain traits that some believed to be desirable were deemed fit to reproduce, while minorities and those with disabilities were blocked from marrying and were even sterilized.
That eugenics movement got way off track from science. Scientists pushed back against this eugenics movement, and by the 1930s, it was effectively shut down in the United States.
Despite this skeleton in the closet, it's important to know our history so as not to repeat it. And from what I see at Cold Spring Harbor Labs today, I think there's plenty of room to be optimistic. When real science is conducted, true progress can be made. And the best place to start is with affected children.
We have worked on a disease called spinal muscular atrophy, which is a mutation that children inherit. The child will eventually die, but the laboratory developed a drug which actually prevents these children from dying and actually gives them a fairly high quality of life.
All this makes me think of young Annabelle Frost and her debilitating genetic disorder. And this kind of research fills me with hope. In fact, genetic engineering can even remedy genetic disorders like sickle cell anemia. Caused by mutation, this disease deforms blood cells into hook-like shapes, which can stick together and cause life-threatening blood clots.
CRISPR is now being used to change genes in sickle cell anemia, where you then transplant back into those patients cells in the blood system that will essentially reverse the sickle cell disease. And so those types of trials are occurring now with CRISPR.
Recently, scientists gene-edited a patient's own stem cells that produce bone marrow. They then re-injected these altered cells back into her body. Amazingly, this therapy cured the patient's sickle cell disease for the first time in history.
Technologies like CRISPR are incredibly powerful and can change the world. They also have the potential for changing humanity as itself.
But there are limitations. The CRISPR technology is not perfect. And sometimes it makes mistakes in the genetic reworking that could be catastrophic. This means CRISPR's implementation directly into humans remains a risky prospect. But one visionary scientist is aiming to give gene editing techniques an even higher level of precision. Dr. David Liu of the Broad Institute of Harvard and MIT is working on tools and techniques that may one day lead to the safe gene editing of humans. He's developing a new gene editing tool called prime editing.
Can you tell me a little bit about your work in that regard?
So the machines that nature provides us, like CRISPR-Cas9, often don't do what we want them to do. The result of breaking that double helix most frequently disrupts genes to cause the deletion or insertion of small numbers of DNA letters at the cut site.
Both CRISPR and prime editing technologies work by cutting DNA. But in some sensitive situations, CRISPR technology can be too blunt of a tool. That's because it breaks both strands of the double helix. In rare instances, this can disrupt the gene in unintended ways. But prime editing is more like a pair of tweezers. It breaks only one strand of the double helix, allowing scientists to very precisely change a single base pair. This is like changing one note in a musical score.
For most diseases with a genetic component, it's believed that in order to treat the disease, you need to precisely change that mutated gene back to the normal DNA sequence.
This ultra-precise technique means David can replace an individual mutation on a single step of DNA and not an entire section of the latter.
So you can make those kinds of changes using prime editors, the kinds of changes that we believe could directly correct genetic disease-causing mutations.
In the lab, David has successfully corrected mutations for genetic diseases, including Tay-Sachs and cystic fibrosis. And he thinks this prime technology will soon be ready to help people with genetic disorders, like Annabelle.
How far off would you say is a potential human application?
We should have some of the first drugs ready by perhaps as early as within the next 5 or 10 years. It's an incredibly exciting time. If you had asked me 5 or 10 years ago, I would have said it still is in the realm of science fiction.
Yeah, that's wonderful.
This experimental technique will become science fact, giving affected individuals the prospect of a better life. But for now, reworking the genetic codes of people remains controversial. In 2018, a researcher stunned the world by using CRISPR to gene-edit HIV resistance into the embryos of a pair of twins. Called germline editing, this technique on humans was considered premature and was widely condemned in the scientific community.
The first gene editing in humans was a profound misuse of science, with profound implications in society in general.
The involved parties were punished for disregarding safety regulations. Fortunately or unfortunately, the Pandora's box of genetic engineering has been thrown wide open.
In many ways, this is one of the costs of doing science. The technology itself is agnostic, it's neither good nor bad. The real question is, what do people do with that technology? And how careful and or mindful are they to the potential unintended consequences that we have?
With the depth of control over evolution that gene editing enables, in breeding plants, animals, and eventually humans, we're entering uncharted waters as a species. It's difficult to draw a hard line between where progress should stop and where our morality or our ethics should come in. Some might argue that some lines have to be crossed to make progress. and there has been much progress, especially in agriculture. Today, more than 90% of corn and soybeans are genetically modified, or GMO. These crops require less pesticide, land, and water. Scientists are also using gene editing to develop crops that are more nutritious and even drought-resistant. Though many in the public remain skeptical, the vast majority of scientists believe GMO foods are safe.
Tinkering with genes for benefit and for good purpose is actually an ethical thing to do.
And as for humans, many believe the benefits of gene editing outweigh the risks.
There are 10,000 monogenic diseases affecting hundreds of millions of children across the world. Precise medicine would help, and then we start building on that.
In the right hands, I think genetic engineering will usher in a much better future for people and our planet. Some think it will even shift human evolution into overdrive.
In 30 years, we may be unrecognizable. I don't think that's going to be our intention, but when you take these big leaps and get comfortable with them, people get addicted.
I'm hopeful that gene editing technology will ultimately help people like my aunt and Annabelle. And for those reasons and many more, I believe the rise of genetic engineering can't come fast enough.